This meeting is being. All right, this meeting is actually in a recording. Okay, so now we are good to go right now. So I'll quickly go and I will open all the required things for us. Just go and do that first of all. That's the very first work. Close this one. Okay, all right. So here, in artificial neural network, I was actually missed the two things, guys. Missed the two things means one is basically best fit code. I was actually missed this one. Okay, so the next thing is the scaling part, scaling the data. Okay, so these two things I was actually not explained well, but don't worry. In a CNN model, I'm going to explain the best fit code, and at the same time, scaling is not possible in a CNN, but I will explain in a next part. Okay, don't worry. Okay, so but our goal is to cover the best fit along with the convolutional neural network in this today's class. Okay, so what we can do is see this artificial neural network is the base for CNN and RNN for everything. So I hope you guys are actually understand so how neural network is actually built, what are the weights, what are the bias, and at the end of the day, how neural network will actually predict the output. I think you get some idea. So artificial neural network, it's not about completely writing down from top to, I mean, from scratch to advance all the calculations for the entire data set. Even your lifetime is not enough to put the calculation on a pen and paper. With a pen and paper, it's not enough. It's all about how it actually works, how weights adjust, how activations works, how loss functions will works, how epochs will works. So I hope you guys are actually understand that building of artificial neural network, right? So you have that learn topic in your mind right now. Okay, so if you understand that how artificial neural network is built, just let me know in the chat box. It's just a pre-required thing to go and talk about the convolutional neural network. Okay, so that's why I'm just asking to you. I hope everyone has some idea how ANN is actually built, how neural network is actually built, right? If you have idea, just type I in the chat box. Yep, Adishish already has idea. Santosh also have. All right. So everyone, I only two guys. Other guys don't have idea, guys. I just need a response in a chat box. What about Monica Chakravarti and then Sriram, Deepthi, Om Prakash? Okay. So even if you have a little confusion, I think if you watch that same class once again, you will definitely get the clarity. Even if it's second time, if you're not getting, you just re-watch that again for third time, the same class, and I'm sure definitely at one point you will get the clarity how end to end the neural network flow will actually works. Okay, so now that's the same neural network here also in this today's class. So today we're going to talk about the most complex thing to understand and to build and everything, guys. But if you understand this one, this convolutional neural network, you will get half of the knowledge to create a model which can generate images, which can identify images, which can do a lot more things. You know, in a recent days, the famous tools, I'll just go and I take a different one. So, right, in our recent days, if ChatGPT gets the popularity by its knowledge, if ChatGPT gets the knowledge, gets the popularity by its knowledge, but Gemini, it's not good if we compare with ChatGPT at some points. But Gemini is super good at image generation and the video generation. Okay, so of course now every tool is good at image generations and then video generations and then everything. There are a lot more tools we have in a market. Okay, so at the same time, not only generating the content but identifying the content as well, identifying the content. Okay, if you pass an image, what is this image, and something like that. Okay, all right, so it may be image generation or it may be identifying the content. It doesn't matter, guys. Okay, all right, so if you see the convolutional neural network which is the best fit for images, dealing with images, videos, at the same time audios. Okay, it is very good, guys. Okay, at the same time it's complex as well, I know this. Okay, but anyway, this convolutional neural network, don't think too much. It is basically a combination of two things, the convolutional neural network. One is convolutional process plus ANN. Okay, it's the combination of two things. So at the end of the day, building neural network for this images is same, for data, for images, for tomorrow other thing also. This artificial neural network and that weights whatever we discussed in a very last class, like this, all the things, forward pass, layers, rules to create neural network, like this all the things, back propagations and the best fit code, everything is pretty common in building convolutional neural network. But the only change here is we have a data. See, let me go with the two cases, guys. Then you will get a proper clarity between artificial neural network and a convolutional neural network. Okay, because if I state the difference, then it's very better to understand. Okay, all right, just go with the difference first of all. If you understand the difference, then it's easy to go some deeper inside convolutional neural network. Okay, if we talk about the ANN, artificial neural network, and of course it works better for theoretical data. Okay, it works better for sequential data is something like we actually take an hard prediction. Okay, there we have hardly, we taken a 13 features where we'll get 13 input layers. Okay, even if it is 130 inputs also, then we will get 130 features also, then we will get 130 input layers. If it is 1300 features also, then we will get 1300 input layers. That's okay, that's all right. But what's the most concerning point with images? If you go with, if you take unstructured data instead of the sequential one. Okay, the unstructured data means, see, in a hard prediction The data is purely sequential. We have a built-in CSV file, which is already built by the developers or any person. It's already built. It has a features like rows and columns we takes and we build. That's pretty easy. Okay, all right. But if you take an image, okay, an image is basically, it has a three layers, right? It has a three layers. So let's take an image of I'll just write a simple image. I'll just do like this. So let's put down here, let's put a cat here. I'll just write like this. I don't know how to write a cat, but I'll just do like this. I don't know, does this look like a cat or not? But imagine it's a cat. Okay, okay. I think the cat is in a vertical way, but it's okay, it's fine. Okay, so all right. So now we have an image. Our neural network, whatever we taken previously, if you just take the neural network, if you go with the ANN, already we have a data like the sex means male means 1, and the cholesterol and a BP. These all are in a numbers 140, 260. That's what we taken in a very last class. So this one we can directly pass to this, to the neurons, and it's pretty easy. Okay, but if we have an image, then how can we pass an image to this neural network? How can we pass this to the neurons? Okay, that's the most concerning point. Now, of course, we can pass, but if we want to pass, one image is basically have a resolution of, let's imagine a resolution of 1080, 1080, 1080 by 700, which is basically the rows and columns. Okay, all right. So that is an image whose size is 1080 pixels width, 700 pixels height. Okay, so it's something like, imagine for the same cat image we give a 1080 whose size is 1080 of width and 700 pixels of height. Okay, so it's not, for me it's not possible to create rows and columns, creating 1080 rows, creating 700 columns. For me it's a big deal. What I will do is, for your understanding purpose, I will just take an image size of 4 by 4. For your understanding purpose, I'm just reduced from 1080 to 4 by 4. Okay, 4 by 4 means the same image will be comes with a 4 rows. Okay, and then the 4 columns. It comes in such a way. Once it comes in this way, and now an image is basically, we have a two different kind of images, guys. Okay, not two different, we have a many more. Okay, but commonly thing is we have a grayscale image, the grayscale image. So the grayscale image is basically a white and black image, which has a white and plus black colors. An image will have just white and black colors. That's it, only two colors. And we have RGB scale images, RGB scale images. So most commonly we deals with RGB class images most commonly. Okay, because who deals with grayscale? Most of the guys, every time we deals with RGB images. That means one image, just a one bloody image, we represent in a three layers. Those layers are basically, if we take like this, see, layer one, we're gonna take layer two, and we're gonna take, oh, oops, RGB. Let's take a red, green, a blue. Red and a green and a blue. Okay. Wait. So we usually have one image. We usually have what? We usually have one pretty common image. Okay. So I'm gonna write down again. It's basically, I'm trying to draw cat. I'm sorry, I was bad at this one. It's not like it's not look like cat, but it's okay, fine. I will write a cat. Okay. So whenever we see the image, it seems to be like this, the flattened one. Okay. But you know, right? A image is a combination of pixels. At the same time, every pixel has its own color, right? If I just go here, if I talk of, if I just take a cat image, if I just go here, see, this is just a one cat image. See, this is one cat image, and this cat image, I will just put into 4 by 4. 1, 2, 3. Okay, let's take more, not 4 by 4. Let's take more. I will just do like this. Okay, so now here, whatever the box, this box, we will treat it as a pixel. Of course, we already discussed one image is this one, and another image is going to be this one. Okay. All right. So now, if you see this, of course, at the end of the day, it's going to be cat. But here, if you see, this pixel is in a white color. In a white color. Okay. This is the pixel is in a green color. If we go, this is the pixel in a black color. This is the pixel is in a white color. Okay. All right. So now this one color we usually represents with three numbers. How many numbers? Three numbers. One color we represents with three numbers. That's what we can say. Red channel, green channel, blue channel. Right? So I will just go here. Imagine I will just put this one into a 4 by 4. Okay. I will just put a 4 by 4. If I just put a 4 by 4, in a same way, we usually gets everywhere it's going to be 4 by 4. Okay, what? We get a 4 by 4. Okay, so I just draw like this. Okay, so in such a way, we get same thing here also, the 4 by 4. I think we got a 4. Yep. So the last but not least, this is also 4 by 4. Okay. So now here I don't have a color image. I don't have a color image, but I will take this image as the reference one. Okay. Now this is the color that we have here. It's a white color. I don't know what exact color it is, but I can figure it out. I can figure it out what color it is basically. So there is a one tool for me. This tool is basically ultimate color picker. Ultimate color picker. So Chrome Web Store. Uh, this is what I want. I will just add this extension to the Chrome. It's added. Thank you so much. Just get back to here. Now I'll just click. Oh, I will just add this to here. Take this. Now can we just go and see? You can see here the pixel. You can see the boxes if you just click on this, and it has a RGB of 141, red is 141, green is just 168, and blue is 155. Okay, so I will just simply go here back with to this one, 141. So red is 141, and then do you remember 168, 155, 168, and then 155. So one pixel is actually denoted like this. Same like we will fill this all the boxes. So one image will be converted into 3 channels. Okay. Imagine one image size of 4 by 4. That means totally 4 by 4, 16. 4 4 is 16. That means 4 boxes, right? How many boxes you will get? 16 boxes. 16 boxes, but it's not 16. It's actually in a 3 layers. So 16, 16, 16. So it is something like totally 3 channels multiply by uh multiply by each size. How much size each has? Each has a 4 by 4 size. Each has a 4 by size, 4 by 4 size, totally 3 channels. So 4 4s are 16, 16 3s are how much? 48, right? Am I right? 48. Okay. So if you go here, in artificial neural network, we got a 13 features, 13 input layers. If I try to solve same problems, not same problems, like every problem with this artificial neural network, then of course one image with a 4 by 4 size, we get a 48 neurons. 48 neurons. Blah blah blah, 48 neurons, and we get 48 input layers. Okay, but for your understanding purpose, I'm taking a 4 by 4. Do you believe an image will be in a 4 by 4? Do you believe an image will be in a 4 by 4? No way. I didn't find any image with a 4 by 4 size. If you go here, if you hover on it, you can see 960. You can see that 960 into 1282. Let's take this 960. Why you opened 960 into 960 into 1282. So 960 into one image is 960 into 1282. So 960 into 1282, and totally how many channels? 3 channels. So 3 multiply by calculator. So 3 multiply by, what is multiplication? 3 multiply by 960 1282. 960 1282. 960 and 1282. If we just put this, oh my god, 36 lakhs 92,160 inputs for one bloody image. For this one bloody image, are you going to create, are you going to create 36 lakhs 92,160 input neurons? Are you going to create, guys? Are you going to create? You, if you want to create, then you need to purchase half of the Nvidia servers. Half of the Nvidia servers. Your laptop will not enough to train the model. So it is for one image, these many neurons. But are you going to do the training with a one image? If you take a 5 images, then 5 multiply by these many inputs. Just imagine how much hard it will be by taking images and constructing a neural network for images. If it is an image, if you take a video have a 60-70 frames, and of course frames means images. Those images again will be numbers. It's hard or not? It's hard or not? Now tell me, do you believe the ANN will works properly for images? Tell me the answer in chat box. Tell me the answer in chat box. Does ANN will works properly for images, guys? Just let me in the chat box. What's your answer? Go. Does ANN will works better for images or not? What's your answer? It works, but after 7 business days. If you train your model today, it works after 7 business days. Okay. All right. It's going to be very hard right now. That's where, to solve that problem, we have a problem solver called convolutional neural network, which is the best fit for images, guys. Okay. Images, videos, audios, for everything. All right. So now I hope you guys understand what is a problem statement with ANN, right? So if you understand, type U. If you understand what's the problem with images and ANN, if you understand, just type U. Then I'll go and I'll talk about convolutional neural networks. Probably convolutional neural network takes, I think, next 3 to 4 classes, because it's a very long one, very big topic. Okay. All right. I hope everyone understand this one. Now what we can do is just go here. So that's where, if you convert an image to the RGB channels, then RGB channels produces these many input neurons. Of course it produces 36 blah blah blah, just a number it produces. But we can give this number directly to the neural network. So once we have an image, we will do here one process. That process is nothing but convolutional process. Convolutional process. So this convolutional process usually includes image RGB channels layer, and it includes filtering. It's a process, guys. Let me just put the process here, not here. I will write in a um, hmm. And this is what I want. You have a good one here. Let me take the best one. Yeah, convolutional layer. Not good one. I'm not getting exact names here. Okay, it's fine. I know what to put. It's fine. It's not giving the proper names. Okay. It is giving directly convolutional layer, but it's not giving what's going on. Okay, but I will write down here. Don't worry. Go here. First we have image RGB layers. Second is we have filter layers. Filter or kernel layers. What both the same, okay? Then after that we have output layer. After the output layer, what we can do is we will apply pooling layer. We will apply what? Pooling layer. Okay. All right. These pooling are three types again. One is average pooling, and we have a max pooling, and we have mean pooling. Okay. So after that, we will get the very fifth one. That's gonna be flat value. Okay. So this is the process that we're gonna follow right now. Okay. So if we're gonna follow the process, you also need to know few the technical terms here. Of course, I will tell you the technical terms while we enter into that convolutional neural network. Okay. So now, first I will tell you guys what we can do is, I already told you, right? So go here. If it's possible to remove this, all this stuff, I can really. Yeah. Just go delete. Thank you. cow. Just delete, just delete, just delete. Yeah, perfect. Now I just got a pure one, okay? So we have an image. That image will be converted into RGB channels. Once we convert an image into RGB channels, then what we can do is, so if you go here, we have a image RGB layers. So these are the image and its RGB layers. Image, and we have RGB layers. Once we have a RGB layers, so in a single time I can't explain by taking all three layers together. It will be a big deal for me. What I will do is I will just pick one layer out from here. Okay, but don't worry, at the end of the day I will comes with all the layers, do not worry. But I need some little cooperation from your side, okay? Because don't skip the listening, okay? Just stay focused carefully. So I will just take one layer from here. The layer is going to be, let's take the red layer, pretty common layer, okay? Every time I'll choose this one. So I'm going to take this red layer out of it. Why? Come, please. Okay. Same red layer I'm taking out, okay? I should take these three layers, but I'm taking just one layer because I will explain you how the entire process will works with one layer. Then that same process we will apply for all three layers together, okay? All right. So I'm just taking a one layer here. To this layer, I'm gonna put so I'm gonna take a 4x4 channel, okay? So because I can explain with you a big one, okay? 4x4, of course, 4x4, 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 and he's also 4x4. Okay. So now, okay, all right. Now here, see, of course, you know, in each box, it's actually a number in between 0 to 255, right? It's 0 to 255. Imagine if this pixel have 138 number. So I will do the normalize. Normalize means I will just denote a number with 255. If I denote a number with 255, then it becomes a number between 0 and 1. Okay, my bad. Imagine if my first pixel is 255, then if I divide this pixel with again 255, then I will just get 1 here. So like that I will put 1, 0.2, and I'll just go with 1, 1, 0, 2. Okay, I will just randomly put the values here, guys, okay? Because right now I can't take exact pixels, right? I'm just taking the random one, okay? I'm just keeping the values here, 3, and just go with 0. Okay, wait, I can't take.
What is that? Why are we dividing the 255? Sorry, I missed.
Okay, all right. See here, each pixel which holds a value in between 0 to 255. I hope you guys
Correct.
are
That
with
is
this
RGB number.
RGB value. So imagine if a pixel value is, just imagine, if a RGB, in RGB 3 channels, R has, first pixel has a different value, this has a different value, this different value. We take a 141 here, right? 141. So if I take a 141, you just divide with 255. If we divide with the 255, then the resulting value definitely in between 0 to 1. So any channel pixel value, if you divide with 255, and definitely I'm sure the value result will be in between 0 to 1. You got my point? I'm just normalizing the values. Okay, I'm just normalizing the values, because at the end of the day, to my neural network, I will pass a value which is in between 0 to 1. That's why I was normalizing the value. Okay, you got
Got
my.
it. Got it. Yes.
So if I just divide 141 with 255 and just go here, 141 divided by 255, if you just do this, we will get a 0.5 something. I'll just keep a 0.5 here, not more big value. Okay, so I'm going to take a 0.5. 0.5. So like we have a different pixels with a different values in the red channel. So right now I can take the channel values exactly, so that's why I will just put a random values here, random figures here. Okay, that random means, let's imagine we taken from an image. Okay, all right. So I'm just put 0.3, and I will put 1 1 1 1 1 1 0.5. Okay, I'll just put 1 1 1. Don't ask me, Prashant, why you're putting more ones. It's my choice. Okay, I was keeping a random values because 1 is pretty easy for me to put everywhere instead of writing 0.5. Okay, so just put this, all the values for the red channel. Okay, all right. Once I put the values for the red channel, okay, all right. So my very next step is I need to apply a filter to this. Okay, I need to apply the filter to this. The best filter I can suggest is a 3 by 3 filter. The best filter I can suggest is a 3 by 3 filter. This this filter is basically comes with a random values. Comes with what? A random values. So why filter? I will tell you. Do not worry. Okay. So this has a random values like 1, 2, -3, and 1, 1, 2, -2, 0, 1. Usually for every red channel, what we can do is, here we don't apply a single filter or a kernel. You can call it as a filter, or you can call it as a kernel. It's up to your choice. Okay, so it's a very first filter, but in a realistic world, my convolutional neural network won't apply one filter. My convolutional neural network will apply 32 filters, or else will apply 64 filters, or else it will apply 128 filters. Okay, all right. More the filters, more the accuracy for the image. Okay, right. So let's keep 32 filters. That means this is a filter with one random set of 3 by 3 values. Okay, there is a one more filter with the same 3 by 3 size, but this filter has a different values. Okay, all right. But I can write a 32 filters here. Okay, let's take a one 3 by 3 filter with the random values, of course. Now what this filter will actually do on top of it? Okay, what this filter do means, this filter we will apply on top of this red channel. Okay, So red channel has 32 filters. Same, these 32 filters we will apply for green channel also. We will take a green channel here and we will apply 32 pixels for green channel, and we will take this blue channel. Okay, then same 32 filters whatever we taken here. See, first we take random values, right? Same random values 32 filters we will put for all three red, green, blue channels of a single image. Okay, so now let's come here. This filter we will apply on top of it. Apply on top of means it has a size of 3 by 3. A size of 3 by 3 means, so you just wait guys, go. See, if you see here, it seems to be like a box. Oh, made it wrong. So we will place this box on top of it. Okay, see, you just look at me. You just look at me in the cam. I hope I was actually visible to everyone, right? I hope I was actually visible to everyone. This is the, see, look at my finger, look at my hand, palm. Okay, so just go back here. This first box is my finger, sorry, my hand. Okay, all right. So then the second one, what you can see here is my filter. Now let's put, see, let's put my filter to this. Okay, all right. If I just put my filter to this, then close. Okay, like contact each other. Okay, contact each other. Okay, so that's the same thing. What I will do is I will just go back here. If I just put this on top of it, 0.5, then I will start multiply the thing. 0.5 into 1, 0.5 into 1, and then 0.3 into 2, and then 1 into minus 3, and 1 into 1, 1 into 1, and 1 into 1, 1 into 2, like that. Okay, all right, just we got this, all this stuff. Okay, so now you can see here carefully. I'm gonna start write the values. Okay, I'm gonna start write the values. So 0.5, 1, 0.3, this one. Okay, if I start write that, okay, just go back here. The next step is, all right, so we are multiplying this layer with this one, but here we have a formula. The formula is n layer n channel layer uh, minus 1, and n layer minus 1, 4 layers, n layer minus 1, into 3, like 4 by 4 layer. Yeah, come on, 4 by 4 layer, and then this is the 3 by 3 layer. So 4 by 4, 3 by 3, 4 by 4 minus 3, we get a 3. Yeah, I was confusing a little bit here. N layer minus 1 and 3. Okay, n layer means the 4 by 4 minus 1 and then 3. Oh, I forgot the formula, guys. Wait. Okay, I'll just go with the calculation. Automatically the value will comes. Okay, so first is the box of this one, and the second is we will just go one step forward, then the box will come this one. Okay, all right, then at the same time, then we will go one step down, then this is the box we will get, and one step down itself, and the next time we will get a box of this one. Okay, all right, so totally how many boxes here we formed? 1, 2, and a down 3, a 4. Okay, all right, so totally 4 boxes we formed. Okay, all right, so yeah, I got it. Okay, yeah, I got it. I can do it right now. Okay, so let's just go here. So now you just focus carefully here. First of all, let's take the first 3 by 3 matrix here and the 3 by 3 matrix here. This 3 by 3 matrix multiply with this one. 1 into 0 0.5, 0 0.5, and then 2 into 0 0.3, it's going to be 0 0.6, I think. And then what we have here, we have minus 3 into 1, it's going to be minus 3, right? And then you can just see here 1 into 1, that will be 1, and then 1 into 1, that will be 1, and then 2 into 1, that will be 2. Okay, all right, same like minus 2 into 1, see, minus 2 into 1, minus 2, and then 0 0, of course, then 1 into 1, that will be 1. Okay, right, so we just got like this, now what we can do is you just take this filter, and first 3 by 3 matrix is completed. Now this time you go one step forward, let's take another 3 by 3 matrix. If you take another 3 by 3 matrix, then multiply, start multiply again. 0 0.3 into 1, that will become 0 0.3, and then 2 into uh 2 into 1 will be 2, and then minus 3 into 1, minus 3. Same like you just start do 1 into 1 1, and then 1 into mid one is going to be 1, and 2 into 1 will be 2. Okay, like that you just start do this entire stuff. Okay, all right, if you start do this entire stuff, okay, so minus 2 into 0 0.5, I don't know, minus 10, I think, minus 0 0.10, I think. Am I right? Okay, same like 1 into last below 1, and then 2 into, sorry, 1, oh, oops, I just made a mistake. 0 into 1, that could be 0, and here it will be 1, and here it will be 1, that will be final one. Okay, all right, same like now, see, it is this one, and just one step forward we got it. If you go one step forward, then we will get just a 2 by 2 matrix, then that's wouldn't be possible. That's why only first one and one step forward. Now you come one step down, if you come one step down, then we will get this matrix. Okay, so then again you start multiply with this one. 1 into 1, it's going to be 1, like this. Okay, then 1 into 2, it's going to be 2. Okay, minus 3, and then 1 into 1 1, and then 0 0.5 into 0 0.5 0 0.5, and then 1 into 2, it's going to be 2, and then 1 into minus 2, and mid one is 0, and 1 into 1 1, we got like this. Yep, all right, so here we go again. So then last but not least, so you just go one step forward, right? Okay, if you just go one step forward, then we will get a 3 by 3 matrix of this. Okay, then you can just start do that. 1 into 1 will be 1, and then 1 into 2 will be 2, and then 1 into minus 3. Okay, all right, so same like that. 0 0.5 into 1, 0 0.5, and then 1 into 1 1, and then 1 into 2 2, and then 1 into minus 2, and 1 into 0 0, and then 1 into 1 1. Okay, so, and if you go one step forward, then you will get only 2 by 2 matrix. 2 by 2 matrix is not at all possible. Okay, so if we apply this filter on top of this one, and this is the box we actually got here. Go, go, go. Okay, so this is the thing that we actually got here, guys. Okay, all right, so now this is okay, this is okay, this is fine. Okay, now this is for one filter, one box, second filter, another box, third filter, another box, like this we will get totally, it's going to be 32 filters, guys. Okay, it's going to be how much? We will get a 32 output, 32 output filters we will get. Okay, this is a RGB filter, RGB layer, and this is a filter we apply, and this is output filter we got it, output filter we got it. Okay, all right, so I hope you guys are actually understand how applied the filter on top of the RGB channel, right?
So why specifically 32? One output I understood. So likewise we need to apply multiple times. So 30
It's a
for the
filters
32 segment.
in a convolutional network, the filters are limited to 32, 64, 128. They just define like that. It's just a built-in one. It's a built-in one
Okay.
in a
Okay.
convolutional networks. Okay, all right.
Okay.
Right. That's why we taken 32 or 64 or 128. Okay, so these are the feature detectors. Like if you have an image, I'm taking 3 by 3, right? So in the first 3, in the corner of the image, it will apply this filter on the corner of the image. In the corner of the image, total 3 by 3, 3 by 3, totally 9, right? 9 pixel it will cover, and in that 9 pixel it will identify the colors and everything, and that identified colors will be stored back here. That means it will recognize each and every pixel, what is the color and how much color look like, is there any corners or not. Okay, black colors, white colors, these all colors it will recognize. So one filter will recognize that one corner, same filter, see, not only one corner, move one step forward, then recognize this part, move one step forward, then recognize this part. So this one filter, if it recognizing all the image, then this is the output. Then second filter will have a different numbers, those different numbers again will start recognize, start recognize. It will find out all the colors, shapes, like corners, everything it will find out, and it stores in another matrix. Like if you take more filters, you will get more accuracy, a detailed image capturing will be happen. More the filters, more capturing, less the filters, less capturing. If you take 128, detail pin to pin every pixel, in that half of the pixel every color it will capture. Okay, so I hope even you're getting, like you should visualize in your mind. Okay, you're getting why we are actually applying the filters to capture the image at every corner, at every point, every color, every shape, and everything it will capture with a different random values. Okay, so one image, same, we take 32 filters, right? 32 filters with a random values. For second image, we will take another image of another cat, cat 2. This is cat 2. For this cat 2 also, same filters we will apply. For cat 1, same filters. For cat 2, same filters. This cat has a different channels. This cat has a different channel values. So at the end of the day, this will be different for cat 1. This will be different for cat 2. So the difference will state different kind of cat images, different kind of capturings. Okay, all right, that's why we are applying the filters for every corner of the images, right? You getting the idea why we are applying the filters? You getting the idea, guys? Just let me know in the chat box. Just let me know in the chat box why I was actually applying the filters. That's the most important step. Okay, that's where the people stuck. Just let me know in the chat box, are you getting the idea or not, why we are up? Okay, Adishesh already got the idea. Because like that blinking effect with the visualization, I can show you, right? How can I show you with a blinking kind of, this is how it captures? No, right? That's why I'm asking to you. Okay, Santosh got the idea, Sunil got the idea, Adishesh already got the idea. What about other guys? What about the other guys? Yes, Bhagavi also got the idea. Yeah, fine. Okay, all right. So now once it gets the output one, it's not yet done, and this is where the step starts. This is where the actual thing starts. So what we'll do is we are gonna take a padding. This the next step is the padding layer. So not padding layer, pooling layer, pooling layer. In this pooling layer, it's your choice. Pooling you can take 3, pooling you can take 4, you can take as much pooling you want, but I will highly recommend just take a less pooling, because to capture the detailed information. So let's take the capture of 3 pooling. A 3 pooling means you take the first 3. I made a one mistake here. The mistake is, I will tell you, don't worry. Not a mistake, I done it right, but not a pooling directly. Okay. So see, we multiplied and we got like this. Once we got like this is the first one. This is a second one. This is a third one. This is a fourth one. Now we need to count this all the values, 0.5 plus 0.6 plus minus 3 and 1 plus 1 plus 2. Count minus 2 plus 0 plus 1. Count this all the values, 0.5 plus 0.6 minus 3, 1 plus, like count this all the 3 values, 0.5 plus 0.6 plus minus 3 plus 1 plus 1 plus 2 plus minus 2 plus 0 plus 1. Count this all the values and tell me the output, guys. Anyone tell me the output by counting this all the values? Just counting this all the box. Count, I don't know, I'm bad at mathematics, that's why. Minus 3 minus 2 will become a minus 5, and 1 2 5 5 will be cancelled, 0.11. I'm faster, I think 0.11. I'm right. I'm right or not, I don't know, because minus 3 minus 2 will become minus 5, 1 plus 1 plus 2 plus 1, it become a 5, minus 5 minus 5 plus 5 will be cancelled, 0.5 0.6 will be 0.11. Am I right? Am I right? I think I'm right. Okay, so same in a way. And if you do this here, then if you calculate, I should calculate, it's become a big deal for me. Minus 3, what is this? What's the value? What's the value? This one, 0, maybe 0, I don't know if I'm wrong. Let's keep 0.
That's 1.1, not minus 0.1.
Which one?
The 0.11, it's 1.1.
It's 1.1.
Yeah.
1.1. Are you sure? Um,
I used color.
I think it's 0.5 into -2.
Plus, right?
Minus 2. 0.5 into -2. That means minus 0.10.
No. I'm talking about the 0 point for first table, all the addition. Right?
Yeah.
I got it as 1.1 when I did calculate.
Okay. 1.1. It's not 0.1. It's going to be 1.1. Yeah. Fine. All right. So it's 1.1. 1.1. Yeah, you were right. 1.1. So same like we need to calculate for this one, and we need to calculate for this one, and we need to calculate for this one as well. So can you please do the quick calculation for this all the stuff? Of course, we should do the quick calculation. If you can do, each guy can do one guys. Okay. Anyone do the first one, and anyone do the second one, anyone do the third one. Do
Second
a quick-
one is 4.3.
Second one is what? 4 point.
3.
Star one.
Third one is 2.5.
2.5. Last but not least, one thing. Last one thing, quickly.
2.5. Again, same.
2.5. Okay, all right. So I just got four things here. So four things will be little
Yeah, how
hard.
did we get these two tables the same? Because we are overlapping, right? They should not be same, right?
Maybe it should be same because of these values. Maybe it should be same, or I don't know. Maybe it's same. It's same both. We have values at this point. At this point, maybe we will get. I don't know. Maybe if I'm wrong in a calculation, or the values are same. But anyway, it's okay. Fine. You got the concept, but don't focus on the values. Okay. All right. Fine. So we got the values. Okay. So we just got this one here. All right. So now to this one, we need to apply the pooling, guys. Okay. The pooling is something like pooling. If I want to apply, it's better to have a one more layer. One more layer means then again I should add, if I take one extra layer here and one extra layer in the below, initial stage only I should do that. Then it will become 1 2 3 4 5 6. Then it will become 6 by 6. 6 by 6 at initial stage only I should do that, but I mess up. So if I take the 6 by 6, like I should take a random values here also, not random values, that RG values. If I take here also, so then we will get some extra box here, extra box here also. Then we'll get one extra box here, one extra box here, one extra box here. So 1 2 3 values, 1 2 3. Then again one extra value will be added here, one extra value will be added here, one extra value will be added, one extra value will be added, one extra value will be added. So let's say that, let's put the random values 0 0.2, 0 0.6, 0 0.7, 0 0.4, 0 0.3. Okay, all right. So if I want to explain the pooling in a better way, with the two values I can't explain properly. Okay, I need at least a 3 by 3 to understand the better pooling. Okay, that's why what I done is I just added one extra layer here. Now it become a 6 by 6. If it become a 6 by 6, if I apply the filtering on top of it, then we will get a big one here. One extra one will be added here, one extra one will be added here, one extra. So one extra 3 by 3 matrix, another extra 3 by 3 matrix, another extra 3 by 3 matrix will be added here. If I'm wrong, you just go and check it. Okay, definitely you will get a 3 by 3 matrix here. If I get here, for this entire thing will be this one, for this entire thing will be this one, for this entire thing will be this one, for this matrix this value, for this matrix this value, for this matrix this one, for this one it's going to be this one, for this whatever we have the last two boxes will be last two places. Okay, all right. So now the max pooling, while you are doing, we have here finally a 3 by 3 matrix again we got it. Okay, all right. So on top of this 3 by 3 matrix, you can apply the max pooling will be 2 by 2. The max pooling will be 2 by 2. 2 by 2 means you take a 2 by 2 matrix first. The max pooling will be three different types of max poolings. One is max pooling. Pooling is three types: max pooling, min pooling, average pooling. Max pooling is we taken a pool size is 2. Okay, 2 means a 2 by 2 matrix. Max means 1.1, 4.3, 2.5, 2.5. All these pooling values, the maximum value is 4.3. From out of it, we take a 4 by 3. Then move one step forward, then apply pooling to this one: 4.3, 0.2, 2.5, and then 0. I don't know what is this. Again, we got a 4.3. So then you can apply. You just go here. So 2.5, 2.5, 0.3, 0.4. 0.4 is the big one. Then 0.7, I'm sure. Sorry, 2.5, 2. Oh, made a mistake. No, 2.5 is the big one. So finally, we got this one for max pooling. But your choice, you can do the max pooling, you can do the min pooling, you can do the average pooling. But if you go with the max pooling, min pooling, it takes a less time when compared with the average pooling. Average pooling means 1.1 plus 4.3 plus 2.5 plus 2.5. All the values will be calculated. We will put a one value. So it is same like whatever we done here. We need to do the same thing here also. But I will go the max pooling because max pooling is good, because see, at the same time, max pooling, average pooling, min pooling, time complexity is same for both all these three. For both all these three, time complexity will be same. Time complexity means like the time which takes to execute, to do the operations for this all the three is going to be the same time. Max same time, min same time, average same time. That's a DSA concept, but let's keep beside. Okay, so you can do anything that you want, that's perfectly all right, but I will recommend just go with the average one. Average pooling is the better one for me, because which gives the average of these all the things instead of giving the maximum one. Okay, all right. But anyway, it's not at all, no documentation there, max, min, average. You can just go with anything because same time complexity. Okay, so once we get the final vector, if you see this carefully here, this final vector, you put it in a stack: 4.3, 4.3, 0.4, 2.5. So if you see this carefully here, one red channel, one filter, one value. In a value, how many values we got it? 4 values we got it. 4 values. See the flow here. One channel, for one channel, one filter, 4 values. But for one channel, how many filters we have? 32 filters. That means 4 into 32 Can you please guess how many values we will get? 8, 12, 128. So for red channel, we get blah 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 blah, totally 128 values. Okay, so that means for one filter this is a value, another filter this is a value, another filter this is a value, total 32 filters, 32 matrices, each matrix 4 values, we will combine these all the things. Then for the red channel we will get a big flatten array. That flatten array is going to be 128 values. You got my point, guys? You got my point? Just let me know in the chat box. So for red channel, how we got 128 values, I hope you understand. Just let me know in the chat box. Just let me know in the chat box. You got the point, guys? How I'm taking a one flatten array? Yes. Go ahead. Yeah. Now one red channel, 128 values, 3 channels. How many values? 128 into 3, right? 128 into 3. Red, green, another 128. Blue, another 128. Now we will combine this all 123s. So 3 into 128. How much? 3 multiply by 128.
384.
384. So finally, an image with a size of, you just go here. What is that? An image with a size of not a 4 by 4, but it's a 6 by 6 because we changed here. Okay. Six by six. What we got it here? We got 384. So for a 6 by 6 image, we get how much? 384.
6 by 6 pixels, right?
Yeah, 6 by
It's
6
not
pixels. Yeah, 6 by 6. 6 by 6 pixels. That means totally 36 pixels. For 36 pixels, it's going to be 384 inputs. So 384 neurons. Okay. So this entire back of the process is nothing but convolutional process. Convolutional process. So convolutional process which reduces the input size, okay, from the image. If you give the image directly, let's calculate. Totally how many? See, 6 into 6 multiplied by 3. How much? 6 6 are? No, something mess up, I think. Somewhere mess up, I think. 3 3s are 36. 3 channels. Oh, I mess up. Yeah, I mess up. Yeah. Come on, the filters is not applied. The filters is not applied because if I take the direct image, then I should apply the filters, 32 filters. Then it's going to become a very huge one, right? 36 into 32. You just calculate. You will definitely get a big number here. 36 into 32 filters on each and everything. It's going to be a very big number. Okay. So but if you do if you do this process, you will get 384 input size. Okay. All right. But if you just do this one, you will get a bigger one. Okay. All right. So that's why we can't apply the filters on a direct image, but we will apply the filter and we will do the a pooling which reduces the size of that input. Okay, then it makes more easy for our neural network. Okay, all right. See, this is just a one layer convolutional process. Convolutional process. One layer convolutional process. But if you go to the image, see, we will do the multiple poolings. Multiple poolings means you just go here, convolutional pooling, convolutional pooling, convolutional pooling. You can do a tons of the poolings. Okay, that means you just go here. Where is that? Oops, here it is. See, finally we got, if you go here, there we got see, we got a pooling one, right? We got a 4 by 4 because of 6 by 6 layer. We got a 4 by 4. If it is a 1000 by 1000, then of course we will get even more bigger one. Okay, we will get what? We will get even more bigger one. This pooling one, maybe, see, if my size is 6 by 6, we got here a 2 by 2. If I take a 1000 by 1000, just imagine we will get a 500 by 500. Then to this 500 by 500, again I will apply pooling. Again I will apply pooling. Okay, then even I can reduce this 500 to even 200. Then this 200, again I will apply convolutional pooling. Then it will be reduced to the 100. So even if the image is so much bigger in size, I can reduce it. I can reduce it, but I won't lose any, that corners. I won't lose, because that corners, everything is captured in the pooling and calculated into the last pooling value. Okay, all right. I won't lose anything of my image, like corners and everything will be captured, but just input size is reduced. But that reduced input size will have all the features of that particular image, guys. Okay, all right. So that reduced flatten array, but don't go beyond this. Just stop up to this one, whatever we got here, 384. Okay, so these 384 we will give to the ANN. Then remaining process is same. Now you just go, we got a ANN layer. Totally how many inputs? 384 inputs. Then you design a hidden layer. Let's say 25 hidden layers. 25 hidden layers. Just blah blah blah. 25 hidden layers. How many output layers? Output layers you need to design based on your output, guys. Based on your output means, if you go to my drive, I told you to upload the images, but only few guys are actually uploaded the images. Everyone please upload the images. Then we have, see, 1 2 3 4 5 6 7 8. Totally 8 people I have. So 8 outputs. Totally how many outputs? 8 output layers. 8 outputs layer. Okay, so like that, here I have a folders of 8, right? 1 2 3 4 5 6 7. Let's take 8 people. Each guy have, let's take 10 images, 10 images, 10 images, 10 images, 10 images, 10. Each person has 10 images. 10 images, 10 images. So let's see how the training process will be happens. In a 5 minutes, I will close the training process. Don't worry, it's pretty easy. So at the end of the day, you got the idea from the images how to get the input. So how to get the input layer, you got the idea. But here there's a one thing that you need to keep, guys. Okay, so you can train all the images directly to the neural network. Okay, what you will do is you just take batch size is going to be 10. 10 means in one process, like we will do the training, right? Epochs. In epoch 1, you can see here how many images we have totally. 80 images. 80 images. In epoch 1, we will train 8 images. Sorry, we will train 80 images. Epoch 1. Epoch 2, again same 80 images in a loop. It runs in a loop. But let's take epoch 1. 80 images, total 10 batches. Like, sorry, total 8 batches, because I'm taking 1, 2, 3, 4, 5, 6, 7, 8, because I can't put all the 80 images directly to my neural network. What I'll do is I will decide a batch size. Okay, for the first batch, let's put 10 images, but the 10 images is not from a single folder. It may be first folder one image, second folder second image, fifth folder image, sixth folder image, and the ninth folder image. Like, it will randomly take some, like, one image from each and every folder. It forms one batch, then put it to the neural network. Then take, see, one batch taken 10 images. First image 384 inputs pass in, goes here, and it generates the output. See, probability for first output is 0.3, 0.7, 0.9, something like that. 2 and then 0.4, totally 8 we have. So one image will generate the 8 probability values here. Highest probability value, imagine 0.9. First person, second person, third person. So who is the third person in my folder? I don't know who is the third person in my folder. 1, 2, 3, Deepthi. So the probability got the highest probability for third image. So that's why this is related to Deepthi. Okay, all right. So in a same way, we will pass the next image. Next image will generate the values here. Highest probability, let's imagine it got for fourth one. So that image is related to fourth one. It don't know who is a Deepthi, who is a Monica, who is another one. It don't know, but the probability makes for third image or probability makes for fourth image. That's how it will say. But we need to find out. So if it is in the fourth place, then fourth place is related to Monica. Fifth place is related to Deepthi. Sixth place is related to Adishesha. We need to decide. Okay, but it will put a similar place. Okay, that's it. Then the third image. Let's put a third image. Third image. It again generates the values, probability values. Highest probability will be related to this one. Okay, all right. So already there is one image here, another image also added to this list. Okay, all right. Like that, it will learns the image patterns, guys. Okay, so which image has the highest probability. Then at the end of the day, we will pass one new image. Then that new image, see, in this training here, weights will be updated automatically. So after entire completion of training, we will get a final weights. Those final weights will be applied to the newly given input image. We will give one image, new image. This image will go to the forward pass, and we have weights, right? Which weights it takes? In the end, we will get one weights after completion of training. That weights it will take, and finally it will generate the probability values. Imagine we given a final image here. That image is related to Prashant. okay? Or else let's take Adishesh Reddy. So it generates the probabilities here. Imagine it got the 0.9 probability here. So this image is pointing to the output number 1. Then I will see who is the output person 1, Adishesha. So that image is related to Adishesha. That's how my neural network will be trained, guys. Okay, all right. So I was just explain last 10 minutes, just a blah blah blah, because you already having some idea on a neural network. Okay, that's why I was explaining the blah blah blah. Okay, the main goal is constructing the input, guys. Once we construct in the input, then remaining process, of course, you know the neural network, how the neural network will works. So we can put actual calculation, because how can I take an image, how can I convert into the pixels, how can I put the actual calculations, how can I calculate the weights? It's not at all possible for a human being, not even, it's not possible for the AI also, it's not possible for anyone, it's not at all possible. It's all about understanding with this little writings and drawings. Yes, this is how it works, this is how it goes, this is how the weight generates. Okay, all right. So while you are listening to this topic, I hope you are getting how that images are being trained, right? Yep. How many of you guys got at least? Yes, it's actually in the recording right now. Let's take a new cell. Let's write a print. Welcome back again. Okay, let's run this one. Yeah, let's change the runtime. T4 GPU, save this. And one more thing, let's do a quick connectivity to your Google Drive. Okay, so I'll just go here because I need this CNN image data set. Okay, so I'll just go here. You can directly connect it to your Google Drive from your Google Colab. Okay, you just click on this one where you can actually, you have an option, right? Just mount your drive here. Okay, click on this one. If you click on this one, it will ask you to connect to the Google Drive, and just simply click on the connected drive. It takes a little time, just we need to wait for a few seconds. Okay, yeah, you got your drive here, and if you click on this one, it's showing my drive. In the my drive, we just go here. Yeah, here we have the CNN image data set. Okay, but if you need to download, it's gonna take a more time. Okay, all right, that's why I'm just taking like this. Okay, all right, perfect. Now I have my data set here, I have everything here. Okay, now what I need to do is, now let's start write the code for our model to train our entire data set for the image prediction, guys. Okay, all right. As we all know, today we are actually building an amazing thing. Okay, I was actually given an intro what kind of project that we are actually building here. Okay, but again, I'm gonna start from very scratch. The scratch means what is a project that we are going to build here, and the data set what we are taking, and then how to train, what are the steps. So let's go one by one. Okay, to discuss this all the things, I'll just simply go and I will take my xcli draw here itself. I need a oh, something went wrong. Extra large. Okay, I just made a small one. Okay, perfect. So I'm gonna keep the project here. The project is basically image prediction, which includes all kind of things, guys. The image prediction, image classification, at the same time, the image generation and everything. Okay, so Probably if time allows, I will be covering here. It's a kind of the image generation project as well. Okay, but anyway, we will build this one right now. Okay, so in the next class I'm going to tell you how we can actually build an image generation project as well. Okay, so for right now, so it's going to be image prediction. So image prediction is nothing but, see, I will tell you a situation. Okay, so it's just something like the door locking system. Door locking, not only door locking system, you can use this in a tons of the places, guys. Okay, so what we can do is, see, we will take few authorized person face images and we will store it inside our a database, guys. Okay, all right, in a database, or you can store wherever you want. Okay, it's up to your choice. Just now we just store in a Google Drive, but you can store wherever you want. Okay, so now we actually stored a different kind of person's data, right? Adishesha Reddy, something like that, and then Deepika, and then Monica, and then Sriram, and then go. What? Who else we have here? We just stored Chakri Sunil. Okay, Chakri Sunil. Okay, all right. Let's go here. Chakri and then Sunil. I think I missed anything. Bhagavi. Okay, 1 2 3 4 5 6 7. I just got a 7 things over here. Okay, so I have only 7 people data. Of course, it's not related to their own photos. It's basically a different people photo, but it's fine even if it's a different one. Okay, so what I will do is, these are the images that I have. I will just put this all the images to my model, my CNN model. I'll just give this all the images to my model. Okay, so this is the CNN model. Okay, this CNN model will actually get trained. All right, it trains, and finally the best model it gives from this, the best model it gives from this. Training will goes here, and this is the trained model, the trained model, and this is basically training process. This training process will actually includes, as we discussed in a previous class, it includes the very first one, that's going to be RGB layers plus RGB layers plus you can see here, see, image RGB layers. The filter layers, of course, we can say the kernels, then the output layer. Okay, so after this we have a pooling, and then pooling, then we go for the flatten array, and finally this all the process is nothing but the convolutional process. Okay, all right, so that's the same thing we're gonna apply here. Okay, so first one is RGB layers, then after the RGB layers we go with the kernels, then we get a output layer, output convolutional layer, or output layer, it's fine. Okay, and after this we are gonna apply the pooling on top of this, and then after that we're gonna get the flatten array. Okay, so this entire process is basically, the convolutional process. Okay, so to this convolutional process, it gives a flatten array. This flatten array will actually become what? input for artificial neural network. Okay, that's going to be ANN network. Okay, fine. Now this process we already discussed, guys. Okay, this process we already discussed. You don't want it to be a misstep of it inside this process. You just need to understand how process will actually works. Okay, that's what we discussed in a very last class. Okay, so even if you have any little confusion, just go and watch that for multiple times. It's not even, I mean, for a beginner, it's not at all possible to understand it in a single take. Okay, if you just keep on watch, then definitely you will get it how those all the things will actually work. Okay, all right. Now this is the same process: RGB layers, kernels, output layer, pooling layer, and the flatten. Only this 1, 2, 3, 4, 5, only these 5 steps will actually include in my code right now. Okay, all right, that's the same thing apart from nothing. Okay, already we are done with artificial neural network, and whatever the piece of code that we've written in artificial neural network, and that's the same piece of code I'm going to write down today here itself. Okay, all right. So the process will be happen here to train the CNN model. Once the CNN model is trained, then we will get the trained model as output. To this trained model, I'm going to give a new image. So what I will do is I will just give a new image, and the process, the prediction will goes inside this one, and it generates the output. It generates the output. Okay, right. If you just see this overall, you will get some idea. Okay, so whatever the image that we given here, it predict and it produces the output. That output may be related to Adishesha or Deepika or Monica, Sriram or Chakri or Sunil or Bhagavi, any one of the person related image. Okay, all right. So now what we can do is, let's go to the image data set. Of course we have a data set here. So Adishesha Reddy is having Mahesh Babu image, the tons of the Mahesh Babu images. I think no images are same. Okay, it's fine. I just got a different kind of images. That's good. Okay. At the same time, let's cross check what Chakri have. The Chakri will have okay, the India, and then what this Deeptya's Rashmika. Fine. And then Monica Hegde, right? The Hegde. And then Bhagavi Cat. Okay. Sam. And then Sriram Nani. Okay, got just a cross checking everything whether we have proper images or not. Okay, so we have Vijay here. Okay, all right. So we have the proper images here. There's a count is going to be 20 here, and I need to check the count as well, because of course you uploaded, I know, but I need to check everything. Okay, 20, even if less also, that's not at all a problem, but it's better to check. Okay, 20, 20, all are 20. Bhagavi, Monica, 20, 20, okay. And then check we 20, this is 25. Oops, 25. You upload more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's fine. It's fine. 25. It's not at all a problem. More we have, our model will works in a better way. Okay, fine, got it. So I have all the data here. Okay, now let's just with the code. Okay, so just go here. Don't need, just close this. Already I have this one. Okay, just give me a second, guys. of it. So as we know that it's going to be 10-step process. Whatever we done in a ANN, that's the same thing I'm going to do here. Okay, so let's start write the code. Okay, so here the one thing I just need to tell you guys. Okay, the thing is, don't be stressed. Don't be stressed about remembering the code. If I'm wrong in spellings, please forgive me. Okay, right. See, don't be stressed about remembering the code. You don't want to remember the code. In the entire world, no developer will remember the code. It's all about a step-by-step approach and proper submission of data. If you submit a proper data and just going a step by step, if you have any error, you just solve it. Okay, so of course I was preparing my own documentation from the past 3 months, and you can prepare you can follow your own documentation. Of course I will give you the documentation, don't worry. Okay, even the revised updated documentation I will give you, don't worry. When not tomorrow, day after tomorrow. Okay, so everything is done, only few things are left. So once I fill that one, then you will get all the calculations wise everything. Even you can get a better documentation than whatever I have. Okay, right. So now let's focus on the process. The process is simple. The process is this one. The process is whatever we done. Oh my god, switching between the tabs. So this is a process. Okay, right. So now just go here. I will start with the very first one. I will write down the steps first of all. Okay, the steps is going to be step one. As we know, it's going to be all required imports. Okay, no, wait. Step one is, of course, all required third-party modules download. Okay, all required third-party modules download. This is step one, and we'll just go to step two. The step two is all required imports. This is a step two. Okay, and then the step three is basically, you just go here. You say here, okay, wait, I don't want to just confuse, I'll just keep everything. All required third-party modules download and imports. That could be Kate, right? Why should I make complex? Step two is just a device config. I was just added only for formality here. Okay, device config. What is this device config? I'll tell you, because we have a CUDA and we have a CPU. Okay, what was that? I'm going to show you, don't worry. Okay, so the device config here, and after that the very step number 3 here, bracket, I'm going to go with the CUDA, or we're going to go with the CPU. Okay, all right, the device config. And then step number 3 is basically image transformation. Okay, so the step number 3 is basically what we're dealing with, the images, right? Image transformation. Image transformation means, I will give you a clarity here. Usually we have a different kind of images, right? If you go here, Adishesha have images. At the same time, if you go here, Chakri, different images. Do you already discussed everyone and uploaded the same resolution image? No, right? Your image size is different. Chakri image size is different. At the same time, Adishesha Reddy's image sizes are different. Okay, so different images, different sizes, it doesn't make sense, guys. Okay, what we can do is, of course, the different images are in a different size. Different size images transform into a recommended size. That's what we're gonna do inside the image transformation. This is what we can say the image transformation, guys. Okay, so my spelling is wrong. Now perfect. Okay, so now just go with step number 4. Okay, step number 4 is basically load the data set from the folder. That's what we gonna do. Load data set from the Google Drive folder. I have a Google Drive, that's why I was saying the Google Drive. Okay, so if you have any other source, you can load from that particular source. And then the step 5. The step 5 is basically the data loader. Okay, the data loader. See, this is basically loading the data set. Okay, I will give a clarity here if you guys will actually confuse. Okay, so this is basically, you have your drive to the notebook, the drive to notebook, and then this data loader is basically, what you do is it came to your collab, from collab to, you just need to load the data to build the convolutional neural network, because you need to read RGB, right? Okay, so that's why we're gonna load from the collab to here. Okay, that's why this data loader. Okay, just go. Now this is the step number 5. Now the step number 6 is, this is where we're gonna the pure CNN model. Okay, so we're gonna build the pure CNN model. Start build pure CNN model. This is what we're gonna build the model. Okay, all right. So going forward, step number 7, and we initialize the model here. We initialize the model means we will create a class here. That class initialization will be done here. Okay, so we initialize the model, and we will take a look into the loss, right? Loss, and we optimize loss optimizer. So all right, everything looks good. Perfect. And then moving forward, the step number 8. Step number 8 is train the CNN model. Okay, the train means the training loop. Okay, here we will build, here we will train means looping. Okay, loop, we will put it in a loop, epochs. Okay, train the model, train the CNN model. That could be better one. Okay, all right. It's something but epochs and weight adjustment, weights adjustments. Okay, you know weight changes, right? How weights will actually change internally. Okay, so then the 9th one, finally step 9, save the best model, save the best trained CNN model. Okay, all right. So if you just see this excludra, we're done with this one, and we will save the trained model here. Then what is the next process? We will apply the prediction on top of this. Okay, what we'll do, we will just do the predict with a new image. The step 10, predict with new image. Okay, so these are the steps that we're gonna follow here. Okay, so now we'll go a one by one, a step-by-step approach. Okay, all right. These are all the steps I was clearly mentioned inside your documentation. Don't worry, guys. Okay, so but again, I'm teaching here. Even the documentation code also available there. But anyway, I'm just keeping here. Okay, so let's start with the very first one. Okay, the very first one is all required third-party modules and download and then imports. Okay, few things will actually not available in a collab. Those things I need to install. Okay, so those are basically I need to install. See, if you need to install any module in a Google Colab, you need to start with the exclamatory mark. We done it. We done this one for so many times. Okay, all right. So I'm just going with the pip.
If we do this in VS Code also, it's the same thing, right? There is no front-end server, web server, nothing. Right?
Sorry, I'm not getting what you're asking.
If we do the same thing in VS Code, it would be the same copy paste of that code, right? Instead of the we put all these third-party modules in requirement.txt and install. That's the only difference, right?
Exactly. You put all the modules to the requirement.txt and you just install the all required packages. Pip install. I mean, pip install minus or requirement.txt. Everything will be installed and just do your work.
Got it.
Okay.
Thanks.
But only problem is here it will be touch, but actual module name is PyTorch. That's where changes will apply. But don't worry, of course, here I will build the model. I will train my models in a collab. If everything works here, then I will make a end-to-end project which includes the front-end servers and back-end servers and API calls. So there you will get it what kind of modules I was actually adding in a requirement.txt. Okay, so my image model is going to be end-to-end. I'm just training the model here. Today I will train the model here. If the model works well, then I will build a front end for this one and we will do the little scale up on that one. Okay, that's what we next class.
Sure.
There you will
Thank
get
you.
it. There you will get it what kind of module names I was adding, because we don't want to blindly trust these imports, because import names little different, actual module name will be different. Okay, that's where we will get errors. Okay, but anyway, I will tell you. Okay, yeah. So people install Torch, and you just go with the Torch vision as well. We do need a Torch vision. Yeah. So then after that we need a matplotlib. I don't think matplotlib is not in there, but okay, it's fine. We don't need this anymore. So we just need the Torch and Torch vision. Of course, Torch is already available, but anyway, I was just installing. Okay, so if I just do this, you will get requirements already satisfied. Okay, we just got this one. Okay, so the step number one is done. Okay, not at all done. It's we need to import other things. Okay, once you've done this, and you just simply comment this because it is installed inside my environment and you no need to install it again. Okay, all right, that's why, because if you just keep this alive, then when you run this cell for the next time also it will start install even if it's already installed. That's why once you install, just comment this. All right, so now just go here. We need to import Torch and then import a torch.nn because I need to build my neural network as ANN. This is what we done in our last class. So let's build just a neural network. This could be better one because whenever we write the code, we usually use NN, a common name. Okay, we don't use ANN. We don't use the customized names because wherever you go, like everyone is just following NN. Okay, so in the same way we follow NN. There is no special documentation, but everyone will understand. NN means the neural network. Okay, all right, so fine. Now torch.nn, and from there we will get NN. Okay, the neural network. Okay, so then after that we're gonna import torch.optim. We need to import the optimizer, right? So torch dot optim. This is basically for optimization. Okay, so then after this we need to take the torch vision from torch vision. This is basically for data. Okay, torch vision, and import the data set and transform. So this is basically for image transformations, because we need to do the image transformation, different size of images to a fixed size. Okay, all right. Import data set, and I think my spelling is wrong. Transforms, transforms. Yeah, it is right. Not at all a problem. Okay, all right. So then I hope I just done almost all the thing. Okay, so now next is the data loader, guys. Okay, so let's go to the data loader right now. So from torch.utils, torch.utils dot data import data loader. Okay, see, torch means, of course, a PyTorch. I told you a PyTorch is a beast which will provide everything for your training. That may be the data training, that may be image training, videos training, everything. You can see here, it supports for building neural network, it supports for optimization function, it supports for image resize, it supports for data loader, it supports for everything. It's a kind of a framework. Okay, it has all the frames. Neural network is a one frame, is one frame, optimizer is a one frame, dataset loaders is a one frame, data loader is a one frame. Combining this all the frames and including in a torch, that's what we can say the framework. Okay, small frames, everything in a one place. Okay, so and just moving forward, we need a uh, image reader. There's a one PIL. From PIL we need to import image. Okay, and import OS, because we need to read the paths. Okay, operating system. Fine, I just got everything. Okay, I think OS is a small one. Okay, I just got all required things here. Okay, so I just taken all the things. I will write, this is for tensors, of course, not only for tensors, for everything, but for tensors, that's the better one. Okay, building CNN instead of CNN neural network. And this is for optimizer function, basically. Optimizer, and the image resize. Size, data loader, image data loader, image reader. Okay, and this is basically for path identification in your operating system. Yeah, so we just done with this all this stuff, and now moving forward to the second step. Let's just go with the device config, guys. The device config is basically, you have a CUDA and you have a CPU. Basically, the CUDA is the powerful one when compared with the CPU. The CUDA is a special made for training a neural network. Okay, all right. So CUDA is basically available in NVIDIA chips. Okay, so let me check the device here. If I want to check the device, I think on a very first day of discussing about the PyTorch module, I was missed this one because I forgot that one, but I will tell you right now. Okay, so that is a one thing that's going to be the torch.device. Torch.device device. This is a method. In this method, what I will do is I will just simply write the ternary operator here. CUDA if torch dot device torch dot CUDA is available. Wait, touch.CUDA is available or not? Let me check. I can check this. Okay, fine. I can check this directly. Print the device. Let me check what we get inside this one. Oops, there's a problem. Okay. TensorFlow has no attribute is available. CUDA has no attribute is available. Torch dot
Spelling of available.
sorry. Yeah. I think I made a spelling mistake here. You can see here AVAI. Yeah, thank you so much for pointing out that. I made a spelling mistake. Just go here. I think I'm right with the spelling. I made any spelling mistake, just let me know, guys. AVILA AVARER. Come on. I think I'm right now. Okay, just go on, run this. Oops, we got a problem again. Okay. What's the problem here? Let's check this one. Didn't match because the invalid type of the Boolean one. Device received an invalid combination of argument got but exponent touch at device. Yes, but what? I'm getting this. The device is available. See, touch.CUDA is available or not. I'm checking. It's available or not. Yes, it's available. You're getting this one. See, the CUDA is available. Okay, fine. If the CUDA is available, of course it works with the CUDA. That means here it's a CUDA. CUDA is available. CUDA is a powerful one. It's not a CPU. So right now the code, everything will works in a CUDA. Okay. So now I'm lucky it works in a CUDA, and I don't need to check anything. Okay. CUDA is a special one which mates for this kind of neural networks. Okay. But anyway, you just comment this because we don't need this. I'm just checking what kind of device configuration I have for this particular cell. Okay. All right. So now the step number 3 is image transformation, guys. Just quickly go and do the image transformation. I just need to do the image. So first what we can do is just take a variable transform, not transforms, transform, because transforms is basically a method here. That's why let's take a transform. Okay. So I'm just taking a transform here. Now you can take this transforms method and you should call this one. Okay. So if you just call this one, not call this transforms dot, which actually gives one method that's going to be the compose. Now inside this you need to resize your image, guys. Okay. All right, so let's take one list. Okay, so inside the list, the very first one is going to be, you need to take this transforms again and you just need to write the code transforms dot resize. There's a thing called the resize, and the resize to what? The resize to it doesn't matter how much bigger the size of the image is, but what we can do is the height and width of the image, you take it like 256 comma 256. Okay, If you take a more size, of course it takes a more time to build the model. So let's take a little less size, 128 comma 128, because bigger the image, more pixels, pooling takes time, and RGB layer takes time. That's why I'm just making 128 128 128 128 is enough for trying the model. So if everything works in a 128, then later on we can change it to the 512 or 256. That's up to our choice, the width and height. Okay, but let's go with the 128 to 128 initially. Okay, so this is what I'm gonna do.
Didn't we didn't load the data by this time, right? Where it's gonna transform?
I will just define my transformation structure first of all. Once I load my data, then I will apply this transformation on my loaded data. Okay.
Got it.
Yeah. So first of all, I need to I need to define here at one place. Okay. All right. I'm just going step by step. Okay. So now I'm defining what could be my image size. Once I define, then I will apply this define. That's why I'm storing my resize information in a particular variable. Okay. This variable I will use in again. Okay. Fine. So now let's 128 128. This is fine. Now the very next one here we're gonna say is, so let's take convert the image to the tensors. Okay. All right. So just pass this the transforms dot two tensors. You know the image, right? Two tensor. This is we already discussed in a we are talking about one dimensional, two dimensional. We already discussed two tensor. Okay. All right. The last
Here transforms is a library.
transform.
Transforms, that is
No,
a predefined library, right?
this is the library. This is the library. Torch Vision is a library.
Oh, okay.
These are classes. Data sets, transforms are a classes. From that classes, resize is a method and two tensor is a method.
Oh, got it, got it. Here transform is a variable, transforms is a class.
Exactly.
Okay. Can we change it to pic size because it's confusing?
Which one? What name you was?
The transform, yeah, if you can change it to picture size or image size.
Okay. So I'll just go with image or else resized image. That could be better.
Correct.
Resized image. Yeah. To avoid confusions. Okay. All right. So just go here. Now, after this, what we need to do is, once we got a tensor, the tensor we do normalize. Okay, so usually we have an image, we get the image and which converts to the tensors, but the tensors I will just do the normalization. Okay, the normalization means let's convert everything into the value in between 0 to c. Of course we will get a values in between 0 to 255, but I will just change everything into 0 to 1. Okay, so to do that I will just put here transforms dot just normalize. You can just do the normalize here. Normalize. To this normalize, we pass a mean and standard deviation. Let's pass mean. Mean is equals to, let's pass 0.5, 0.5, 5. At the same time, I'm gonna pass the standard deviation std, comma 0.5, 0.5. Okay, perfect. And everything is done here. Now, just cross check once. If I just go here, if I just print resized image, and let's see what kind of information we usually get. Okay, oops, we got a problem here. The problem is, just check this one. different size image transform into recamera 1. The thing is, the line number 7 is focusing on inverse modes mapping I. Just a cross check once we made any mistake here, not 128, 128. The resize, yeah, I just made a mistake. You can see here. The thing is, this should be in a tuple. This should be in a tuple. That's the mistake I was actually made. Okay, just go here. This should be in a tuple. Now it's perfect. So transforms dot two tensors. This is okay. This is not at all a problem. And then yeah, everything looks good. Just run this once again. Yeah, everything is good. Okay, so fine. We got this one. This is also properly working. Okay, so now everything looks good. Now what we need to do is, let's just simply go and load the data set from the folder. Okay, all right, so this step number 2 is also completed. So this is the same process you will do for every image processing, guys. Okay, every image processing, just load these modules and then define your resized, the recommended size image structure. Just define, just see the code and write it down. That's not at all a problem. Okay, then once it is done, your resize formation is done, then you just go and load your data set. That could be from any source, maybe from database, maybe from Google Drive, from your local device. It doesn't matter where it is from. You just load the data set from your required source. My required source is Google Drive. Of course, I was already connected to my Google Drive. Now I need the entire folder. Okay, I'll just click on this one. I will go the copy path and I'll just take this one. Now close this one from here. Okay, so now I'll just come here. So I will just simply keep my data path, or directory. You can just take anything. Okay, so instead of taking the path, you can take my directory. Okay, so my directory is my folder. Okay, so my data folder, my data set, my data folder path. It's even more beautiful. Okay, my data folder path. So the data folder path is going to be, you can store it in a string. Okay, this is my data set folder. This is where my data is available. Okay, so once you just done this one, now to load this data, my image data is equals to load this data from this URL. What we can do is, we take the help of this data set. We take the help of this one. We just put the data sets. It's basically a class. This class includes one method that's going to be image folder, because you need to you need to read the data from folder. You just take the from a folder. Okay, to this you need to pass your root. A root means from the folder where you're taking your data folder path is your root. Okay, all right, so just pass your root. Root is equals to data folder path. It means it reads all the data. It reads all the data from this particular path. Path means from this path, and then once it starts read, then you need to resize all your image. Okay, then I'll just go here. I will just simply pass, there's one variable called transform. So you need to transform. This is a built-in one, guys. This is a built-in one. Root and transform is a built-in one, but data folder path is your choice. And the transform means it reads the data, right? But the data should be comes into this resized image. Okay, all right, that means my transformation. Someone asked, you are defining, right? So now this defined thing I'm using here. Now it reads the data. Now all data will be converted as per this 128 into 128. I hope you now you got the idea, right? I don't know who asked. I don't know who asked, but you got the idea right now where I was
Yeah,
trying.
yeah, yeah. Here transform is again variable.
Yeah, it's not a variable. It's the built-in parameter that we are passing here. The built-in one. This
Oh,
is a,
okay. It's a predefined parameter. Okay.
you don't need to create your own. You should pass this parameter default. Okay, all right. Yeah. So then you just go here. Let's check whether it is really reads our data or not. Okay, all right. Can we check the folder names what we have inside our main folder? The main folder is CNN image dataset. These, see, if this is a folder, then we can say these are the subfolders, right? But usually, if this is a folder, then these will be treated as a classes. Adishesha class, Chakri class, Deepthi class, Monica class, Bhagavi class, Sriram class, Sunil class. So my code will actually treat these all the things like a classes. So I will take my class names. So my class names. So usually my image data, to my image data, I will ask my subclasses. My subclasses means my classes. If I ask my classes, it returns all the classes into these class names. Then you can print your class names. And we are just checking if I'm getting the class names. That means I have printed, I have successfully loaded my Google Drive data. Okay, let's just go and run this. Fingers crossed. Yeah, it works. There we go. You can see here. Okay, this is because of this print statement. I don't need you. Just go. Run this. And we got Adishesha, Chakri, Deepthi, M. Monica, Bhagavi, Sriram, Sunil. I just got all the folders here. So successfully my data is also loaded. So this is how you need to check. Okay, so I'm not only writing the code, I'm just checking every point at every type. Okay, I'm checking and then I'm going forward. Okay, so now the data is loaded, guys. Once the data is loaded, then what's our next step? The step 5 is just go and do the data loader, guys. Okay, the data loader means in my last class, I don't know it is available or not. Yeah, it's not going below of this one. Yeah, I was better just bulk out the things. It's fine. I don't want to go here. So in my last class, I told you, right? We have a data. So I will fix my batch size. My training will be happens based on a batch size. Batch size means we don't give all the images at a time for training. What we will do is we will send a batch wise 16 images, 5 images, 10 images. It's up to your choice. You can send a 10 10 10 10 10 images. Okay, all right. So I'll just go to my collab and I'll just define my data loader here, how I'm going to load my data to the training. Okay, so I'll just go here. I don't need this because it is working. I don't need this. Remember these class names. Okay, I will raise this again in the last one, prediction part. Okay, so the data loader, where I will go, my batch size, I will just define my batch size. My batch size, you guys tell me how many images I need to send for batch wise. Can I send it 15 images? Of course 20 we have, but I will send a 15 15 15 15 15. Okay, all right. Every epoch will take 15 images. 20,000 epochs, 20,000 into 15 times. Okay, all right, then image, then you need to decide how many times the epochs will actually works. Okay, so now the batch size is 15. In each batch it takes a 15 images. Then you can define your data loader here. My data loader, is equals to, so you go to the top where we have a data loader. This is the function where we takes this. Okay, to this we actually need to pass your image data. Okay, your data to this. At the same time, you also need to pass your batch size. Oops, I'm taking the same names here and here. It's a little confusion. That could be better one. Okay, my batch size is 15. Like total images for batch. This could be better one. Now I'll take this one. Now it's one. Okay, so batch size is equals to total images per batch. Okay, I'm just passing. See, I can directly give this 15 here also. I can give directly. That's not at all a problem. But for your understanding purpose, I'm separately created one variable. I'm storing here. I'm just passing the value here. Okay, don't confuse. I'm storing here. I'm just passing here. Okay. Then next thing is you need to keep here. You need a shuffle or not. You need a shuffle means taking the shuffle is the best one. Shuffle is equals to so shuffle means if you go here, we have images 20, 20, 20, 20, 20, 20, 20. So first it takes 2 images here, it takes 2 images here, it takes 2 images here. Totally size of my batch is 15, right? Per batch it should take 15 images. Epoch 1, it takes 2 from here, it takes 5 from here, it takes 2 from here. So it takes the randomly. To the epoch 2, it will shuffle. It will shuffle. All the images will be shuffle. Okay, all right. Then again start takes 15 images per batch. So I'm just saying here, for every epoch, just shuffle all the images. Okay. So when you shuffle, then the shuffle is basically to take a different kind of images at each epoch, guys. Okay, all right. So that's why I'm just doing the shuffling here. You can say the false shuffle will not be happen, but do the shuffle for more accuracy. Okay, all right. So I hope you got the idea. So I just done this, all this stuff, and then you just print the data loader here. Just do what we get. Okay, so fingers crossed. Yeah. So we actually working. It's working, not at all a problem. Okay, so let's just close this. Now start build your pure CNN model. Okay, as I told, while I was actually building my CNN model, I will just simply start with my class. Building model means class, guys. In the ANN also I'm taking a class. Here also I'm going to take a class. My class is, so here we are building a simple CNN model. Okay, right. I can say a pure CNN model. It's a pure choice. A pure CNN. Okay. The pure CNN we are building. To this pure CNN, take if you want underscore. Okay. The pure CNN model we are building. I will remove this model. I don't like this. Pure CNN. So this pure CNN takes column. Now inside this, it has a 2 methods. One is, def underscore init for all class variables. Okay, print class variables. There's one more method. The method is the forward method, because we need to pass all the data to the neural network, right? Def forward pass. We do the forward pass. Forward method consists always the self. Self is a keyword, and of course you know what it does. Okay, we do pass, we do forward pass, passing data to the inputs, data to input neurons, and building weight adjustments. Okay, all right. So these two classes, two methods I'm taking here. Okay, once I was taking a two methods, so I will just take this pure CNN, initialize the model, and loss optimizer. So this is where I will just do my model initialization. Okay, so my model is equals to this one. Okay. Can we run and can we check whether this is working or not? Okay, if I just run this, if I print, okay, we don't want to print as well, because whenever model initialization is done, automatically the init method will be called, right? Just go and run this. If I just run this, you can see here all class variables, because this is a constructor method. Constructor method automatically executes whenever the class is basically initialized. Okay, all right. So this class is also working. Now this is where all our logic will be written, mainly in a forward. The construction will be done in a forward. Okay, all right. Let's quickly go and do this right now. Okay, all right. So to do this, I just need to go and I'll just go here first of all. This is just a normal class right now, the basic class, normal Python class. But to build a neural network, I need to give a superpowers. Where I will get the superpowers? From this torch, I will get a superpowers. So from this torch, from this neural network, I will import neural network dot module. This is where I will get my superpowers to create a layers, input layer, hidden layers, those all the stuffs. So I'm taking a neural network module. From this, I will just simply go here. I will call one super method. Okay, super, where I will, the super is basically to initialize all the weights, all the basic weights. Okay, the random weights we will take, right? Those random weights will be initialized at super method. Okay, so inside this one, I will just simply pass my view CNN, and then I will just simply pass myself. Okay, I've passed this one. I just need to put a comma and then init. Okay, all right. So I will take one special class for this one. Understanding this one in a deeper way, we need a deeper knowledge. So this super method, I will tell you, do not worry. Okay, all right. So now just keep this one side of your brain. I will tell you. Okay, all right. So here all the weights initialization, random weights and biases. This should be done. Okay, all right. So this is fine. Now let's build our a convolutional layers here itself. Okay, convolutional layers. Let's build here. So first I will do to myself, I will attach everything to myself because I need to use that variables in my forward class. That's why I will attach whatever I was creating, whatever the variables I was creating, the class variables, I will attach to the self. Self dot. First I will create my convolutional layer 1. Okay, my convolutional 1 is equals to, I'll just simply say that my NN, my neural network, just create a convolutional 2D. Convolutional 2D. You just go here, PyTorch.nn, where I can see the pooling layers, convolutional layers, right? If you click on this one, say you have a convolutional 1D, convolutional 2D, convolutional 3D, you have a tons of things, but I'll just take the 2D one, okay, which applies the 2D convolution over an input signal composed of several planes. Okay, that means it applies the 2D layer over here. Okay, all right, I'll just take this one because I don't need any other stuff. Okay, all right, I'll just go back. Same like, see, for convolutional this will be this one. For building the neural network, we just shown, right, input layer, that will be the linear one. Okay, all right. At the same time, for building the recurrent neural network, where we have a recurrent layers. Okay, all right. So we will use the different kind of layers, guys. Okay, so right now we are building the convolutional neural network. That's why I'm going to use this one. Okay, all right. I'll just go back here. I'll just simply write my convolutional 2D, and I'll just pass this one to the 3, and then 32, and then my kernel size, my filter size. Okay, my filter size is basically, I will take kernel size, let's take 3. Size 3, and a padding of 1. Paste convolutional 2. I will explain why convolutional 2D 1 and 2 and 3. I will explain this one. Just have some patience, because at each point we will recognize the different kind of things. Okay, 1, 2, 3, and then 2D, 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 3 to 32, and 32, size 32, 64, and size 64 to 128. 128 is more than enough. Don't go for the 256. Okay, so at each point my kernel size is same and my padding is same. Okay, right, I have all this stuff. So at see, I told you the basic structure of convolutional neural network. That means the convolutional layer, and you have a kernel, and then you have output layer. Then you have what? See, I will just show you this one. You have a RGB layer, that means the input layer. You have a kernel, output layer, and a pooling. Okay, this is a one step. You can take layer, kernel, output, pooling, again a kernel, sorry, again a, the RGB input layer and kernel and output layer and a pooling. You can do this process for 10 times also. If you do the 10 times, then 10 convolutional will happen before getting flatten array. Okay, 10 times 10 convolutional will happen before getting flatten array. Even if you see here, CNN images, oops, see, if I just take any image, see the input, of course they're taking directly kernel. Oh my god, they're taking directly just one part, they taken a kernel. I don't need this. I'll take a good one. They directly taken a kernel. Yeah, this is the better one. Okay, you can see here the input, the convolutional 1, 2, 3, 4. You can take a 10 convolutionals, the 10 poolings. Okay, after 10 poolings, we will get the one, the flatten array. Okay, all right. You can do the 10 poolings, the 10 convolutionals, but I just told one input and one convolutional and then one pooling. Okay, but you can do as many things you want. Okay, if you do the more things, then the bigger images, the bigger sizes will be reduced. Okay, that's why. Okay, just go back. But here, the one thing, the main thing that you need to know, 3 to 32, 32 to 64, 64 to 128. Okay, all right. At each place, it recognizes the different kind of patterns, guys. Okay, all right. So at very first point, the first point means the inside 3 to 32, where it actually recognize the lines, the edges, the corners. Okay, here it recognize edges, corners, image corners and image edges and the lines, where at 32 and 64, which recognize eyes, comma nose, and then mouth, other body parts. Mouth, other body parts. Okay, where we have 64 and 128, the full face, and then that's it, the full face, or else the any person's specific parts.
How do we know that? Is it based standard one?
What?
How do we know if we take this size, the size and nose will be in the same position? Is it
This
standard?
is a standard one, 3 to 32, 32 to 64, 64 to 100, the standard ones. You can increase this one, 128 to 256. The more you go, and it recognizes even in a specific parts, the detailed structure it will recognize.
But if I give, instead of a face picture, if I give a full picture, right?
Yeah.
Is it still same applicable here?
Yeah, it will apply the same thing.
Okay, got it.
So now, yeah, so everything is done. You just take the same thing. Okay, all right, you just take the same thing. Even if you need a even more detailed description, you go for 128 and 256. Even 128 is a peaks one. If you need even deeper, very much deeper, take 256. Okay, 128 to 256. But this is more than enough. This is how everyone will use, every machine learning developer will use. Okay, all right, that's it. So then now we actually defined all the convolutionals here. Once we define all the convolutionals, the very next step is basically you go and build your pooling. Okay, all right, you just go and build your pooling. Just make the pool, the self dot pool is equals to, I'll make the maximum 2D pool, my neural network dot, which actually gives the variable max pool 2D, because you taken a 2D, take a 2D pool. Okay, all right. If you take a 1D, take a 1D pool. If you take a 3D, and take a 3D pool. Okay, I'm taking the 2D pool here, which is going to be 2,2. Okay, all right, that's it. And then these are the fixed things. Okay, these are the fixed things that you need to follow here. Okay, so then finally let's make a fully connected layers. Fully connected layers. Okay, so the fully connected layer, first one fully connected layer, second one self dot fc1. Fc1 means the fully connected layer 1 is equals to, I'm gonna say that, just make it a linear one. Okay, I'm just building my input layer here, so which has 128 is a peak one. Okay, all right, multiply by 16, multiply by 16, and then if you're taking the 128, then you just put the 256 here. Okay, and then copy paste my fc2 nn dot linear, and then whatever the 256 that you take in here, you put the same 256 here, and the number of classes, you put all your classes to here. The number of classes means the classes that you taken in the top. Total class. I might define the length of my classes. I think I'm not defining any length of my classes. My bad. You need to define your length. Class length length. The class length is equals to be, there's a default method, length of len of my class name. Then you take the class length and just put back here. So this is basically your output layer. The output layer is basically your total length of the classes, right? So totally 7 people's 7 outputs. Okay, I don't know 7 people or 8 people, I don't know, I didn't count. 7, right? Yes, total 7 people. That's why total 7 output layers. Okay, all right, so I'm just taking, because my folder names are my output layers, right? That's it. So I'm just taking this one. Once I just taken this one, then what is going to be the next piece of work? The next piece of work is, I think almost I done here, the fc1 and the fc2, the fully connected layers. Now let's go and let's simply go with the forward one. One thing I just missed, guys. Okay, the last thing is the relu. I think I missed. Okay, so everything is done. The just only one thing is pending, that's going to be the relu. Okay, the self dot relu. I'm just going to be say that nn dot everything is done. Okay, so fine. See these 2 lines, sorry, these 3 lines, sorry, these 4 lines is a fixed lines, guys, for every model. What you need to do is just define your pool, and if you're taking the convolutional 2D, please take the max pool is going to be 2D, and you just pass 2 by 2, that's enough. And if you're taking the 3D here, then the max pool 3D is also available. If you're taking the 1D, and the max pool 1D also available. So whatever the thing that you're taking here, just take the same thing here. Okay, and one more thing, whatever your maximum peak one here, that peak one multiply by 16, multiply by 16, and then what is the 128 after? The 128 after is going to be 256. Just take that one. Okay, then you just start with 256 here, and you just go with output layer. It's something like your input will be 256 and the produced output will be 256, and the total number of output layers are how many? Class lengths, because you can't fix 5 or 6 or 7. You can't fix the fixed number here because we don't know how many subfolders. That's why whatever the subfolders that you are reading here, the total count you need to pass here. That's the rule. Okay, all right. then just make the ReLU. If you make the ReLU, then all the, the complete, the bias calculations and everything, the hidden layer formations, everything will be happens here, and everything is done. Now you just go with the forward pass. Okay, all right, so almost everything is done. Once we done the forward pass, then we will just go and we will train our model, guys. Okay, all right, just go and quickly do the forward pass here. This nn.relu is pretty common in all the neural networks. Okay, all right, so now we don't need this anymore right now. So first of all, let's just go with my x. I'm going to take here. Okay, you need to take the self comma x. Okay, this x you should take here again. Okay, this is the default one that you need to take it in every forward method. Okay, and self dot pool to this pool. Okay, self dot pool. Just pass self dot relu to this relu. You need to pass your convolutional one, and to this let's pass your x. That's it. Yeah, so which is basically for 60 128 to 64. This is okay. Copy paste. See, pooling again, a pooling again, a pooling. Okay, I'm just doing 3 poolings here because 3 convolutional layers. That's why I'm taking 3 poolings. If 2 convolutional layers, then we do 2 poolings. I told you, right? The process is, if you go here, 1 image layer, 1 filter, 1 output layer, 1 pooling. 2 image layers, 2 filters, 2 output layers, 2 poolings. 3, 3, 3, 3. That's how this process will work. Okay, that's why I'm taken 3 convolutional layers and the 3 poolings. That's it. So in each pooling, size is higher, then decrease the size, then decrease the size. So to get the clarity, the very first pooling, the size will be so much bigger. Let's say that 128, because we taken a 128 is the highest one. 128 by 128. In this pooling, the 128 will be reduced to 64, 64. 64, 64. Then the second pooling, the size of the pooling will be reduced from 64, 64 to 32, 32, 32, and 32. Okay, so then after this, the 32, 32 will be reduced to 16, 16, and finally we reduced to 16, 16. 16, 16. Even though if you reduced, nothing will be removed. It grabs all the required features to this. Okay, all right. So only change is 2, because 2 and a 3, and rest of the things are gonna be the same. And that's it. We just made everything here. Now finally, this is same x I was updating here. X is equals to, just flatten. Okay, after doing all the pooling, you just go here. See, 3 times convolutional, 3 times pooling, and finally we got our x. Final pooling one. This is that final pooling one. You need to make it a flatten array. Let's do the flatten array.
So here pooling also xxx is the same variable, or it should be
Yes,
x1, x2, x.
see, this is the first pooling. You will get a bigger matrix. Pooling 1, you get a bigger matrix. Pooling 2, same matrix. This size is 128, 128. And you will get a smaller one. 128 will be decreased to 64, 64 in the second pooling. Sorry, here 128 to 64, here 64 to 32. Then in the third pooling, this one will become even smaller one. This one will become 32 to 16. So now it's a 16 pixels. I mean 16 by 16. 16 by 16. So 16 by 16 means I don't know how many values totally. Now this one will become a flattened one. Flattened one means the vertical values that we can directly pass to the neural network. You got my point? You got my point?
Yeah, I got.
Like each stage, see here x will be 128. Here x will be 60. Like the keep on decreasing. Same x I'm updating. Finally, I will get the required x here. That required x, I will make the flattened one. Okay. So let's make the x dot view. Not here, my bad. X dot view and x dot size of 0. We have a 0, just make it a flatten -1. Okay, which makes the flatten array. Okay, perfect. And then the structure I'm defining here. Okay, then oops, 0. I pressed the O here. That's not a O, it's a 0. Okay, now the same x, I'll just take the ReLU self dot, you just go with the ReLU and self dot fc1. To this fully connected layer, we will pass our x again, because we need to pass the inputs. The flatten array will become an input for fully connected layer 1. Okay, and this input layer will become an output for the fully connected layer 2. Self.fc2. Okay, right. So yeah, done. Everything is done. Return x. Yeah, it's done, guys. Okay. Now just simply go this. Let's cross check everything. I just made everything here or not. 3 convolutionals I'm taken. Okay, so then one pooling I defined here. Then apply the pooling on this one. 3 poolings I made. One flattener I got, and that flatten array I was given input to my first layer. First layer output will be stored here. That output I'm given to the second layer. That's it. And finally, this layer will decide the output, and output I'm returning here. Okay, everything is done. So now go to the optimizer, the last optimizer. The model is equals to the pure CNN. This is where I just made this one. Okay, now you just say that loss is equals to, you just get My neural network will give everything. Neural network, just take the cross entropy loss, and then my optimizer is equals to, so only one step pending. That one step, if we finish, then we will go for testing with a new image. I was eagerly waiting for the testing, so whether it will works or not. Just go with the optim. My god, so much code. Optim dot, we have Adam Smith. Adam, okay, Adam. The model, we need to pass like an input for this one. Parameters. Now is equals to 0.001. Perfect. Optimizer. The default values we actually pass in here. Once we pass in this one, now what will be our next move? The next move is still a red color underscore. Why? Go. Optim dot. Why this red color underscore still? Okay, it's fine. It will be gone. Don't worry. So now just go and take the epochs. Let's take the epochs. Number of epochs. I'll take 10 epochs. I think 10 epochs is enough for me because images 10 epochs. Runtime disconnector. Reconnect again. Now it works. Okay. Number of epochs. Images don't need more epochs. Okay, you just take a very less epochs, like 15 epochs is more than enough. Okay, let's take this one. For every epoch in range of number of epochs, this code should be here. Okay, my model, just you use a variable called train. Model dot just train. If you just say the train, my model will be trained automatically. Okay, all right, just go and initial running loss should be, I'm taking 0.0. Okay, so now what we can do is, for images comma labels in my data loader, guys. Okay, my data loader, in my data loader, images comma labels is equals to, let's give my images labels to images to this images image we need to give this to the device because the CUDA is available, right? If CUDA is available, I will give this all the data to the CUDA. Images to CUDA. to the device, but I'm not given this one to the device, right? So I should give this to the device, but device is not declared. Let's go and declare the device. Let's declare a proper device. For better and faster performance, okay. Torch dot device of. So I will write a ternary operator here. CUDA if torch dot CUDA is available. Is available. Else it goes for CPU. Okay, perfect. See, if torch.CUDA is available, it goes for CUDA. Otherwise, it goes for CPU. That's the output will be stored in this device. And that, say, if it is a CUDA, we will give that all the data to the CUDA. If it is a CPU, we will give to the CPU. Okay, that's what we're doing. So this device, I will just go and I'm just using here because I will give everything to my device. Okay, all right. Once we given to my device, after this one, image to device and labels also to the device. Labels, my labels also to the device. Device. Okay, right. So I'm just given everything, my labels and everything. My optimizer is basically the zero gradient. Optimizer is basically the zero gradient. Okay. Outputs is equals to my model. I'm getting still a problem here. I don't know what's the problem here. I was still getting this kind of red color underscore, but it's fine. I don't know why, but if we get error, we can solve it. Okay. So I'll just go here, parameters, one r is equals to this one. IR is equals to, okay, it's fine. We will see any error comes or not. Zero grade model of the images. Yep, perfect. Now the loss finally. Loss function is equals to my loss, which take my outputs and my labels. Then if we get any loss, just go and back propagation and take a optimizer step. and then running loss is equals to running loss, say this running loss plus loss function dot item to predict the loss. Print the epochs here. We can track the logs here. Okay, we can track the that entire epochs. What is the loss at each and every point? I'll just make a F and take the epoch. Epoch plus 1 taken by number of epochs. Number of epochs. So epochs is basically this one, and number of epochs is basically number of epoch. Perfect. And once we made this, just put it's too crazy one. The loss will be running loss divided by length of data loader. Where is the data loader? Data loader. It's a tough deal. Colon dot 4f. Perfect. I just made everything here. Now, oh my god, save the model and just go ahead. Torch dot, just save the model. Save and just do this one. Let's put the model. My model dot state detect. Comma. Save the model with, we saved in a pickle file, right? But here we saved in the PDH file. Okay, right. So let's say that CNN image predictor dot pth. Okay. PTH means the PyTorch file. Okay, don't confuse. We save in a pickle file, but here it's going to be the PTH file, which means the PyTorch model file. The extension will be .pth. Okay. So fine, this is done. Just to cross check everything up to the save model. And the only pending is just we need to predict with a new image. This is where we need to focus right now. So I think I just done with almost everything. The only one thing that is left, that's going to be predict with the new image. Let's pass the new image directly here. Once we pass the new image, then everything will work. Okay, so just quickly go and do this prediction as well. Once we're done, then we are done with this entire model. Okay, I think hardly it takes up 3 to 4 lines, not more than that. I'll just go with testing image is equals to testing image path. I will pass the path here. Let's just say that predicted class. What is the predicted name? Predicted name is equals to let's go here. Predict image oh my god, def predict image. I'll make it a little faster here. To this is class print predicted image here. I will call this class in the below. To this one, I'm gonna pass my testing image path. This is the variable I will pass here. So it stores this one inside here. I'm passing arguments and parameters. Okay. This testing path I need to pass, but where can I pass? I will just go and I will download one image. What image I will download is I will just download NTR image, because I will take one NTR image. Let's take this image from here, copy, save images. This is my testing image. If I run the model, if I submit this image, I literally don't know whether it will predict properly or not. Let's see what it will do. Okay, I'm just taking one image. Go back here, upload the image here, guys. Let's upload this one. Just copy the path. Yes, let's pass the path here. Okay, so this path will be given to the predict image. See, this is a function. To this function, I'm passing like an argument here. Okay, all right. Once we pass this one, it goes here. Now inside this, we need to write our prediction logic. Okay, all right. So let's just say that model dot eval, and then image is equals to image dot open. So this image is basically from here. We actually taken a class here just to open. Yeah, this one. Okay, this is the image reader. I will just pass my path to here. Now let's just convert this one to the RGBs. Convert to RGB red, green, blue channels. Once we convert, the same image I will update. Just transform my previously taken image. Just transform and unsqueeze. Okay, I'll just put the unsqueeze here. Unsqueeze is basically to convert. I mean, just add a one dimensional. Okay, unsqueeze to 0. Unsqueeze. Yeah, it's done. Now transform. No, I think I made a wrong one. resized image. Yeah, perfect. Okay. On a final image to device, let's give my image to the device. Yeah, that's it. And with torch dot no grad output is equals to model. To this we will pass our image. Predicted torch dot output comma 1 return to class names predicted item. Yeah, but this is not a class names. What name I'm taking in the top? Oh my god, huge code. This is class name. My god, I just mad. Because we use a return, right? If I'm using a return, and I should store this one in a separate variable. Print the prediction. Oops, it's done. Oh my god, I lost half of my hairs, guys. Almost I set up everything. I'm sorry guys, I missed a little explanation from here, from the epoch onwards. From this part, I just completely missed explanation. I'm so sorry, because I need to just speed up the process. So almost everything is done. So this code is same, guys. You just need to change the path. The rest of things are going to be the same. Okay, that's why I was just gone through with all the things. Okay, in a fast way. Okay, so I think everything is done. Still it's showing the red color underscore. I don't know why, but we will run the model and we will see whether it will work or not. Okay, if any error we faces, and I will change accordingly. Okay, so here we go, 3 2 1 and the bam. Oops, we got a problem. Let's check the problem. So it's basically, oh, we got a problem last time also at the same place. I think I'm gonna remove that. Go. Problem again. Let's check the problem values. Got an unexpected keyword, kernel size. We got an unexpected keyword, the kernel size at convolutional 2D init. Okay, let's go and take a look into that one. So unexpected kernel 332. Okay, kernel size, that's right. Padding is equals to 1, padding is equals to 1, convolutional 2D, convolutional 2D 332. Ah, my bad, it's kernel. Bad at spellings. Let's run this. Oh, it starts running. 1 second, 2 second, 3 seconds, 4 seconds, 5, 6, 7, 8, and time's up. Oh my god, we got an error. So name labels is not defined. Labels is not defined to the device. I think I'm not defined the labels. See, for images, labels in data loader, images and labels. Ah, cross check once again. Running loss. Ah, this is where I made a mistake. Even finding the lies is a big deal. Can you please help me out? Where is that particular line, guys? The labels. Oh my god. Spelling mistake everywhere. Labels. Copy. It's not a labels, it's labels. 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 Bad at spellings. One second, 2 second, 4 second, 5. Oops, got a problem again. Zero grade is not defined. Zero grade is not defined. At output models images labels in the same place again. We got a problem. Optimizer is optimizer not is equals to dot. Go again. 3, 2, 1. Pam. Still how many errors we will get? I don't know. 4, 5. Oops, got a problem. Let's remember what is the next error. The next error is should be the same. F dot convolutional 2D. Written F dot convolutional 2D. Input weights bias, self stride, self padding, self dilation, self dot. Outputs models of images. Line is showing the problem at this place. Images outputs. God, how many errors I'm gonna face? Let's go back again here. For images comma labels in data loader, same images I'm taking here, the labels, and then images to the device, comma, labels to the device. It is right. Then what's the problem? Return F convolutional 2D. Okay. My bad. Oh yeah, it's a tough deal. Where can I find that one? There is no proper description here. In type torch CUDA float tensor and weight type torch float should be the same. Aria, I'll take the help of my Cran because I can't figure it out right now. Time wasting. Just take the Cran help. Ah, come on. Input limit is 1000 characters for longer inputs. Please visit. Oh my god. Cran chart. I missed somewhere. Help me out. But you never moved your model to the device. So when you do images labels to device, output sees model. Images are on GPU, CUDA, but model is still on a CPU. Hence the mismatch. How to fix it? Okay. This one also I need to add to the GPU. All my images are in a GPU, but my model should be also into the GPU. Now one line, I think. Just go and fix this. Where is my model declaration? Where did I call my model? Here. Let's run this. If I get any error, I'll take the help of this one. Okay, all right. 1 second, 2 second. Don't give me any errors. Fingers crossed. Please make this to be work. 6, 7, 8. 8 seconds means I think it will work. 10, 11, 12 seconds. 13, 14, 15, 16, 17. I think it will work. I think it will work because it is taking more time. The training process is going on. 24, 26 seconds, 27. Don't give me error, please. Just go. 32, 34, 35. Just keep on count because we taken a more images, guys. That's why it's taking more time to just process it. We need to wait for some time, okay? Going on. One minute. Just wait and you just sleep for some time, guys, okay? Until it runs. Don't worry, it gives the output at the end of the day. It runs, so I don't know what will be the output. I will just scroll down my screen and I will check. If I get NTR, then I'm the most happiest person. I'm the most happiest person ever in the world. Trust me. So I will see the output will be our class. The output will be our class. It may be Adishesha, it may be Chakri, it may be Deepthi, Monica, Bhagavi, Sriram, or Sunil. I don't know which class name we will get, and let's just see that. Scroll, 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 scroll. Keep go, keep go, keep go, keep go. I got a Sriram. I got a Sriram. I don't know Sriram is NTR or not. Let's just cross check. If Sriram contains NTR, then bam, I'm the most happiest person. So here we go, Sriram. So I'm just opening. I don't know. I literally don't know. I forgot which person is in the Sriram. Okay, just go and bam, we got a Nani. Okay, all right, we got a Nani. Okay, fine. Let me try with a different image. Are it's playing with me. Is that NTR look like the Nani? Let's try with a different image. I will try with a gull image, guys. I will try with a gull image like the Pooja Hegde because more similar features. I will just try with this one. The less data it will mess up with this. Don't worry. Save images. I think we have a Pooja Hegde, right? Pooja. Don't don't say Rashmika for this one. Just go and do this. And also I take another image. No, it's fine. One image is fine. Just upload. Can I take a 10 epochs here? I will run once again. Meanwhile, I will. Yeah, for every model run, we should wait for some time. Let's wait. Same model, what it will give. We need to wait once. I mean, the 1 minute. There is no chance. Oh, it's run. It runs in a faster way right now because the 10 epochs. Let's go. We got a checkry right now. Let's go and see the checkry or not. Okay. I don't know checkry will have NTR or not. Check in a checkry's one. Checkry one. Bam! It matches. It matches with the NTR. Can I just try with I think 10 works better maybe. Okay. Just check with the Pooja Egg Day once, then I will get confirm. Okay. So if I just check with the Pooja Egg Day, just go and run the model again. I will upload the Egg Day photo. I will check with every different person and let's see the model works better or not. Okay. So let's go with the Pooja. Upload it. Copy path. Don't worry, it reads the WebP also. Okay. JPG and it supports for this one also. Just run the model again. So this is a Pooja Egg Day. I don't know. I saw somewhere Pooja Egg Day in our model in our folders. And let's see, does this will give a proper Egg Day label or not? Sorry, proper Egg Day class or not? 10 epochs totally. It got a Sriram. Sriram is what? Nani. Egg Day is not Nani. Okay. Oh my god. It's working in a different way. Why Sriram attracts every time? Nani. Okay, don't worry. Let's try with the one more image. So almost it will works. The model is not 100% accurate one. Okay, so let's try with the one more different image. Can I try with the Rashmika ones? I have already a Rashmika in my place. I will upload a Rashmika. So let me just download all the people, whatever we have. Nani. Okay, I will just take. I will take this image. It works better for NTR. I will upload these two. Nani. These two things I will upload. Let's check with a Nani copy path. Let's put down here copy path and just take this one as well, and then just put back here. Let's see the model will works properly or not for both of them. Copy path and just paste it here. Prediction 1 and a prediction 2. So first one should get Nani, second one should get the Rashmika. Okay, just go and run this and see what we get. Okay, going forward. So one I got Sriram, second I got Deepthi. So I think Nani get matched with Nani finally, because Sriram is Nani, I think. Sriram is Nani, I think, right? Yeah, Sriram is Nani. So it Nani is matching with Nani. Okay, all right. So at the same time, who got Rashmika? Rashmika got Deepthi got, right? Deepthi got Rashmika. Okay. I don't know Deepthi really contains Rashmika or not. Right. So it's working good. It's working good. The model is working good. Okay. I can't give the 100% surety, but the model is almost working good because the less images, that's the problem. If you give more images, then it works in a better way. Okay. All right. 20 images, right? How it will work better for 20 images. Okay, fine. Got it. But it's working good. Okay. Let's just try with a different image. So I'll just go with one last time. I will check. Mahesh image. Okay, let's try with the Mahesh image. If it gives Mahesh image, then I'm sure we made a great model. Okay, I'm gonna take this one. Maybe the haze and all the look like the Nani, but okay. If it gives Mahesh the model, then trust me, we build a great model. Save. I just made the save here. Just go back. So what I will do is here I will just change everything whatever I done previously. I will take the Mahesh picture, copy path, just set the path here. So just test it out. So just hope on a fingers crossed. All right, epic 1, 2, 3, 4, 5, 6, 7, 8. Keep go. And then Monica. Oh my god, got a Monica. What is inside Monica? Puja Egg Day. This guy is matched with Puja Egg Day. I don't know, guys. At some point, it is giving the accurate results. At some point, it's literally messing with us. Okay, let me try with this image, copy image. You try with the different images, guys, and it works. You give a 40 images, it will definitely works in a better way. Okay, so I will try with this image once. Check all the possibility cases. Mahesh 2. Let's go and just download. One last check with me. Okay, if I check, then I will just bind up, guys. It's too much time. It's 4 o'clock. and I will just open. Okay, so just change Mahesh to, just run it. At least give me this one, Mahesh. Don't disappoint me in the end. Sriram. Sriram is Nani, right? My bad. Sriram is Nani. At some point it's giving go. At some point it's literally working very very bad. Okay, right. Um, it's fine. That's because of this image data. Only you have a 20 images. That's the problem. Okay, but the model is working fine. That means it's giving the results, but not in an accurate way, guys. Only few things. Drashmika got the correct answer. Intia got the correct answer. Only few things. Nani also one time we got a correct answer. Okay.
Prashant, shall we take same image which we download and test it?
Which image?
Which are already in Google Drive.
Or in a Google or Drive?
Yeah. Yeah, you can keep this image and test it.
Okay, you need a same. In that case, definitely it works good because we take the same image. Yeah, let's try with the one. So I'm gonna take the drive, my drive, and CNN. Let's take the Bhagavis one this time. The Samantha image. I'll take this one. Copy path. Okay, so go on runs out. Seven and then 8 and then 9 and 10. It's getting the Bhagavi. It's working well. The Bhagavi. Okay. And if you're testing the inside one, it's working good. But if you're testing outside one, because that features is not learned by this model, right? That's why you need to give a more knowledge. You need to give a more knowledge to your model. Okay. If you give a more knowledge, then definitely it will work well. Okay.
Yes, Prashant. Yeah, understood.
Because it never learns the patterns because we don't have that kind of images. Of course, we have a little patterns, but not matched well. Okay, right. So you try with the 40 images. I will share a source where you can actually get images. Okay, where you can actually get images. Your task is find out I will give a X-ray reports. I will give, it's a very realistic one. You can build a great model where we can get so many images. I will give a X-ray reports. You know X-ray, right? Images. I will drop that source. You know the X-ray, right? Yeah, this kind of images I will give you. Okay. So what you need to do is you need to predict, guys. You need to predict. I will just go where I written. My bad. So you need to predict the disease, guys. Okay, so you need to predict what you need to the pH. I don't know pneumonia spelling, that's why I'm writing the pH. Okay, all right. So the pneumonia, the disease you need to predict. Okay, this is what you need to predict. You don't need to do anything, just I will give you the data. This is the code. Just replace your source here. Once you replace your source, the rest of the things will actually works better. And you test it with any new person x-ray and just find out that this is what you are actually getting. Okay, all right, I hope you will do this. So this is your task. Okay, I know the very less people because I'm taking so much time. It's nearly 3 hours or 2.5 hours, I literally don't know. But finally we just build a model here and I'm very happy with this one, guys. Okay, all right. So anyway, okay, you just go and take a look into this entire code once again. Just go through with the code line by line. Okay, all right. You don't need to remember the code, of course. I will give the documentation. Just follow the documentation whenever you are building the particular model. Okay, and the data sources, you need to work with more data sources. I will share the 10 data sources with the different kind of images. Okay, I will give the problem statements also, what kind of problems that you need to solve with that image sources. If you solve those 10 problems, okay, that means you are an amazing guy inside a deep learning building models. Okay, all right, that's what you need to do. So today I'm gonna share by the end of the day, today or tomorrow, I'm sorry, tomorrow, because I need to sleep right now. So tomorrow I'm gonna share all the 10 sources, not one, it's gonna be 10 sources. And the problem statement also you will get it in a PDF, and just you need to solve it. You need a patience and just building a step by step. Okay, all right, that's it. And you can leave right now and it's done. We are done with this one. Okay,
Okay, Prashant. Thank you so much.
all right, it's actually in a recording. Okay, so today what we are doing is, in our very last class, of course, we built a great model. We trained on a data, of course, the less data. So finally the model is working. Okay, now let's make a end-to-end app. Okay, so let's set up APIs and let's set up a Streamlit. And in the Streamlit, I will tell you how can you just send your image from your Streamlit app to the backend. Okay, so let's go and discuss those all the things quickly. Probably I'm going to take 40 to 50 minutes of class. I hope I will complete in just a matter of 50 minutes. Okay, so let's quickly go and do this. Okay, so I'll just go, and I don't need any roadmap today because the only thing that I need is the collab. There's some small changes in a collab that I need to do. So let's go and do the collab changes first. This is what we need actually. Just go to the below. Yeah. So we have our model code here. This is what we actually written in our very last class. So let's quickly go and let me mount my drive. Yeah, my drive is already here. It's already mounted. Okay. Now, from my drive, I think I was taken in the CSS image data. What data we are actually, giving input here. Let's see. Testing images, drive, my drive, CNN, the Bhagavi. Okay. The testing, I'm just giving sam1.jpg from Bhagavi. Okay. So this is the image I'm giving as an input, and it should predict. So if you get Bhagavi, of course we got it Bhagavi. Okay, but let me run this model once again. So why we need to run this model once again? Already we have the CNN image predictor PTH file we have here, the PyTorch file we have here. Inside machine learning, while you are building the machine learning, we generated .pkl file. So once we generate a .pkl file, every time you don't wanna run your model and it takes some time, it's going to be very hard thing. Okay, so once you have a pickle file, then the new test data you will be apply on the .pkl file. Okay, that's the same thing here. We have .pth file, that's the PyTorch file. Okay, see, if I'm running my model, for every new testing image, it's taking time because the entire model is coming to the training and then executing. It's taking some time, right? So we store best weights here. We store the best weights here. Once we store a best weights here, then when we take a new image, this new image we will apply it directly to the best saved model. Okay, because you don't want to run the entire model again. You don't want to run because the best model will automatically saves inside this code. If you go and you can see, oops, got it back. Just go back here. My bad. Go. I was come back suddenly. Here you can go. You can see here somewhere I was saved my model. Yeah, if you see this, save the best trained CNN model. Once we saved, then we will get this one. Once we get this one, then you don't need to run this entire model again. Okay, all right, so let's do the little changes here. Little changes means, let me run the model once again. See, for every new image, it is taking more time. Okay, so we got output as a Bhagavi. The model is working fine. Okay, now what we need to do is, let's test with the second image. Let's test with any other image. Let's go and I'm gonna change the path. Okay, I'm gonna go with the checkery this time. Let's take this path, or else let's take this image, copy path. So if I pass the path here, every time it is taking time to run because the entire training is going on. Again, the file will be generated, that pth file will be generated here. Okay, again everything, right? So but we don't want to do like this. We just need to save one pth file is enough. Okay, so that's why what I'll do is I will do a little changes here. The little changes are basically, let's close this. Yeah, Chakri, it's working good. I got the best one. Okay, so let's go here. So here, if you see carefully here, model.evolve, okay, and image.open RGB, this is okay, convert and unsqueeze image to the device. Okay, all right, see, we are just giving this image. The image will be stored here. The image we are passing here, and we are converting into the RGB, and unsqueeze will be done. Then image we are keeping in a device, and then we are just predicting here. Okay, all right. So what I will do is, this prediction code I will change, guys. Okay, this prediction code I will change. I no longer go with my entire training process because I have my a pdh file here. Okay, I have my pdh file. I will load this file here, then I will do my prediction on this particular file. Okay, so let's quickly go and do this right now. Okay, so to do this, I need to do a little changes here. Let me just go through with the code. Yeah, here I save my model. Oops, inside the function. I just go here. Let's say that model is equals to the pure CNN class. I should call again. Oh my god, what should I change here carefully? Let's close this one for some time. Ah, yeah, it's confusing. It's confusing. Okay, wait. I will write down everything in VS Code. I will definitely confuse you because I don't have the line numbers, the closings, and I don't have those ones. Let me just write everything, the code to the VS Code, and let's start do everything in a VS Code. Okay, that means let's set up all our front end and a back end. I will do directly changes in a front end. Then I'll get some clarity. Okay. Mm, After a long time, again we are going back to the VS Code. This is a different one. We don't need this anymore. Let's take new folder. Yeah. Image predictor. Backend. App.py. Requirements.txt. Server.py. And then requirements.txt app.py. Perfect. Let's quickly work on the Streamlit. Okay, let's go here. Let's take the Streamlit. Just give me a second, guys. And we need a request. Okay, this is the two things that we actually need here. Close, 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 close. And I hope you all guys remember what we done in a machine learning every time. And I don't want to teach this again. If you forgot, please wake up and just look back to the previous classes, guys. Okay. So the CD, I need to say that front end. And what's the first command I need to execute? Can you please put it in the chat box, guys? What's the first command I need to execute here? I'm just reminding to everyone. I don't know whether you forgot this all the topics or not. That's why I'm just reminding. Okay. So what is the first one that I need to execute? Just put the command in the chat box quickly. Just put the command inside the chat box. I have my front end. What's the command I need to do here? I hope you remember. I'm waiting for your response, guys. Just keep the front end, the commands, what I need to execute. Hey, why you guys are silent? Are you forgot, guys? Are you there really in the class? Bhagavi, Chakravarti, Sriram, Sunil, Ashish, Santosh, Adisha, Om Prakash, Deepthi, and Monica. Yeah, what's the command? You remember the command?
I don't know the command, but actually, I think we need to activate the path.
Okay, the virtual environment. Fine. Okay. All right. So most of the guys are actually forgot. I think. Yeah, we got a long gap. That's why you guys have forgot. Okay, it's fine. Okay. So let's add one more thing. We actually need a pillow as well. Don't worry, I will tell you. Okay. So here, first let's create a virtual environment. Python -mv nv. So virtual environment is created. Then we need to activate. Okay. So source /bin/activate. All right, and then clear, and then pip install. How can you forget this, guys? Pip install -r requirement.txt. It cuts all the packages. Yep, we got all the packages here. I hope now you got the idea. Okay, it takes a little time. Go to the app.py meanwhile. Finish it. Yeah, it's finished. Now you just import all the required things here. The very first thing that you actually need here is the Streamlit. Let's import st. Okay, Streamlit.st. So I will import request later on. Okay, so let's say that st.title is basically we can say the image prediction using CNN model. Okay, so this is what we taken. And what is the command to run the Streamlit app? Can you please put that command in the chat box? Go, everyone. What's the command? You forgot. Everyone forgot. Just got a 1 week, 1 or 2 weeks gap, and you forgot. Streamlit run and the file name. Exactly. Okay, so let's go here. Streamlit run and then app.py. So we got image prediction using CNN model. Okay, so now let's go and do all the setup to upload your image from your local device. Okay, all right. So we already discussed uploading your files. Okay, so let's say that let's upload your file. What do you need to upload? You have a built-in Streamlit method that's going to be st.fileuploader. Okay, so then you're gonna take this. We already discussed the entire Streamlit, guys. Okay, so now I'm using the same methods here. So here you just say that upload your image. Okay, so and also you just need to specify here the what kind of types that you are actually allowing here. Okay, the type attribute will actually specify what kind of type of extension that you are allowing here. Okay, so let's allow the JPG, and then let's allow the PNGs format. Let's allow JPEG format. Probably this is the extensions that we have in our images, that WBP we have, but I don't need that. I just need this kind of extensions. Okay, so just got all the extensions here. Okay, so now the next step is just go here. All right, so let's take a button. Okay, so we need to take a button. Click is equals to st dot button upload image. Okay, if click happens, then we need to print upload file and see whether it actually works or not. Okay, so st dot text is equals to image is taken. Okay, so let's go and test this. Just refresh the page. All right, so now just browse the files. Once we browse the files, and we got image here. Okay, let's take any one image. It's fine. I'm just taking this image. If I click on the upload image is taken. We're getting this one, and if you go back here, yeah, so it's properly working here. Okay, then no problem here. Now what we need to do is, the next step is we need to, if you see here, the upload file, you are getting just a file information. This is just one file ID we are getting, the name we are getting, the type of the image is JPEG we are getting, and you can see the size is going to be the 7114 something we are getting here, and then the file URLs, file ID, you're getting all this stuff. But this is not the actual image data. The image data you will actually get if you read that image, guys. Okay, if you want to read, if you go here, you have the pillow, right? So this is the library where we can actually going to take the help. Okay, so just say that from pil, that means the pillow. Okay, import image, where it reads the images. Okay, so now what we can do is you just need to read the image. Let's say the image is equals to, so let's take the help of this one, image dot, just open up. Okay, just open what you need to open, the uploaded file you need to open. Okay, so once you open this one, what is going to be the next piece of work? Okay, so the next piece of work is you can check the st dot image is basically, you can pass this one here, and then the caption is uploaded image. Caption is equals to, you just put the uploaded image, LOADED, uploaded image. Okay, right. So everything is done, and what we need to do is let's test this same thing again. Okay, all right. So use the container width. There's one thing I just actually missed here. That's going to be use container width. Just give me use column width, not a column width. It's container width because it's an image, right? So let's keep a true. Yeah, perfect. All right, so everything looks good. Let's go and test this right now. Okay. Refresh the page. Browse files. The 200 MB only you can apply here. You can upload here. Take this image. Open this image. Okay, so you can see here you are getting whatever the image that you taken here. Okay, so this is the image that you actually taken, the nani dot jpeg 7.1 kb. Okay, all right, it's working good right now. Okay, so upload. See, you can actually get the image here. Image is taken. Okay, so this is a uploaded image. This is the image you uploaded. Okay, then in the below you will get the decision. Don't worry. Okay, all right, so what kind of image it is. Okay, so the decision we will get only if you add all the backend APIs and everything. Okay, so we will do that. And before going to do that, what we actually need to do is there's a one small change that we need to do. Okay, from that uploaded file we need to get the value, guys. Okay, so just go here to the Streamlit. This is not the actual thing that I need. I need a different one. I actually need the file content is equals to, from the image, from the uploaded file you can actually get the value. From the uploaded file you can actually get the value. Okay, now let's print the file content. Refresh, browse files, upload image. Yep, just go back here. Yeah, this is what I want. Okay, all right, so you know, right, how to read the files in it reads in a hexadecimal format. So it finds this is the data that I really want. This is the data I will send to my backend. Okay, all right, so this data I need to send, this is the image data, because you know, right, how Python will actually reads our data. I already told you, right? Okay, so we just got this one, and this is the data I need to send it to the backend. Let's send this file content to the backend, and what we need to do is just we need to call the API here. So let's call the API. Import requests requests as req. Okay, then you just put result is equals to request dot a post method, because we are uploading the image. Let's upload the image. Here we keep the backend URL, of course, you know, right? Backend API endpoint we will keep here. Okay, a backend URL plus API endpoint, and the data we will submit here. The data you can just submit, you are submitting the files. Okay, if it is a JSON, that could be a different one. Okay, the JSON data is different one, but you are submitting a file. Okay, if you are submitting a file, then you need to go with an attribute called files. Okay, files, PDF or anything, PDF or any file. If it is a file you are submitting, JSON means you will use a variable called JSON. That's what we done in our previous class. Okay, but we are sending a files, right? So then you need to say that files. Okay, so then my API will understand, okay, this guy is sending the file information. Okay, this file content we just need to send here. Okay, all right, I hope you guys understand what I'm trying to do here. So while you are sending here, also you need to send it like a JSON format, but the JSON format is, you just need to send it like an image data. Okay, what is the image data you are sending? Your file content is the image data. Okay, all right, that's it. We are just done with everything here. There's nothing left here. We just kept everything. Okay, now let's cross check once again everything. I think I just made everything. Okay, but still we have a red color one. Why the red color one? Maybe because of this one. Yeah, now it's okay, looks good. The backend URL we will quickly set up, because I need to create my a backend server as well. So let's quickly go and do the backend server, and we will come back here and we will put the URL here. Okay, all right. So before going to the backend, I hope whatever the small piece of code that I was actually written here to send my image to the backend, this is a small piece of code I was written, of course, in a Streamlit. You guys are here been for the last 2 months, 2.5 months. We worked on so many Streamlit files. I hope you understand. No, nothing issue, right? Yep, I hope you understand, guys. Just tell me in the chat box. If you understand, type U in the chat box. I was waiting for your response. If you understand, type U in the chat box. Yep, Adishesh already understand. Sunil understand. Santosh. Okay, all right. Monica Bhagavi. Okay, everyone understand. Perfect. So now quickly go and just set up the backend. The backend hardly takes 30 minutes to set up everything, all the APIs, everything end to end. Okay. Go here to the backend. Let's close all the front end. We really don't need this now. I'll come back here again. So let's go here. So let's add all the required things here. The requirement.txt, everything. The Flask we need, and the torch we need, and then the torch vision we need. Okay, and also we need the pillow we need, and then the numpy we need. Okay, I'm just taking all the required things here. Okay, now I just need to take my new terminal here, because this is the front end terminal, and I need to take my new terminal. Again, same thing, cd backend, and you need to create a virtual environment again here. Okay, let's create a virtual environment. Yep, it's created. Source vnv slash bin slash activate. Oops. Oh, come on. You see v and I just said okay, it's fine. Yep, it's generated, and we don't need this because of course it's not a problem, but we are going with the proper naming conventions. Just go with the v and v. Okay. Yep, it's activated now. Pip install -r requirements.txt. So I hope it takes some more time because there are powerful modules that we are actually installing. Okay. So you can see 79.5 MB, that one touch, 1.1 MB, 2.1 MB, and you can see here this is going to be nearly 79.5 MB. That's going to be the touch. Touch is a huge one. Is this done? No. Yeah, it's done. Okay, so just go back to this sow.py, and of course you know, right, how to create our APIs in a Flask. So most probably this will be my last Flask app because I will be entering into the generative AI soon, where I will teach you the fast API. Then our life will be with the fast API because of course the fast API is a faster one when compared with the Flask. Okay, that fast API soon we are going to work. Okay, so probably this one, or else one model is pending, that is recurrent neural network. That one thing is pending. Once we are done with that one and we no longer use the Flask, it's always a fast API. Now import Flask, sorry, from Flask import area. From Flask import Flask, and you also need one more thing, that's going to be JSONify. JSONify request. Okay, I just need this, all the three things. I just done this, all the three things. Okay, now app is equals to Flask of this, we pass __ name, app dot run debug is equals to true, @app dot route of get, okay, sorry, slash the basic one, methods is equals to get def home return JSONify. So I'll specify here, this is my home path. Okay, so yeah, it's done. One API we actually built here. So let's test this. Okay, so Python and server.py. Yep, it's working, and this is the URL it's actually generated. Let's go and test this URL. This is my home path. The API is properly working, no problem. Okay, just go back, and we need to just integrate this API URL to the front end. Okay, so I'll take this API URL. Okay, of course I need to build my another API @app.route. So the slash predict, this is the API I'm taking here, def predict return JSONify. JSONify. You put a message. Here is your results. Okay. Just run again. Okay. So let's take this URL from here. So it's going to be API URL plus API endpoint. Okay. I'll go to my front end, app.py. So here you pass your backend URL first, then API endpoint slash predict. Okay. So and also let's quickly do here. Once we call this, if I okay, just do it directly. Okay, I don't need any little validation here. Okay, let's just say that JSON off. I'm directly converting into the JSON. s.json is equals to the result. Okay, let's quickly check this one, what we can actually get. Okay, I'll go back. I'll go to my Streamlit. Of course, I can click directly. Okay, let's just refresh the page. Browse files. You can see 405 we are getting. Okay, it's fine. Let's upload. Let's open.
Run the backend server.
Backend service.
Is running. Oh, okay.
Okay, we uploaded an image, but what are we actually getting here? Okay, expected a value line 1, column 1. Okay, fine. I just got a problem here. I can solve the problem is basically do not use in a production. The problem is not here because you will get a 405. Okay, anyway, let's check. I think the problem is from here. Don't convert directly. Let me check first. Print results. Okay, not results, result. Let's also cross check your backend once. I think no problem from the backend. I done properly.
Method equals to post you need to mention that.
Yeah, exactly. Fine. Thank you. Methods is equals to post. Perfect. And now go back and test this. Yep. Okay. And now here only let's put .json because I need to convert this one to the JSON. I don't want to maintain a separate file, separate variable. And now let's put the test.json off. That's going to be the result. Okay. Now just do it again. Yeah, working. Okay, it's properly working right now. Now just we made the both servers conversation is successful. Okay, all right, so now both servers is actually communicating each other. This is fine. Now the front end setup is also done. Now the most complex part is just doing the backend setup. Okay, the backend API setup. All right, reconnect. Now I need to copy the code from here step by step, and I just need to paste it in my copying for the first time. Pasting will become harder, but anyway I can do it. So let's go. First of all, let's take all the imports from here. Go and keep all my not here. Let's close all the required stuff. I don't need you anymore. I will keep everything here. Yep, I just kept everything, the torch and then torch.nn, and then I just kept everything here. Once I keep this all things, okay, the very next step is you just go back and you need to generate your model first, then you need to do all your remaining work. Oh my god, tough deal. Which is the best approach, guys?
We can copy paste the same code instead of writing again.
Copy paste the same code, but the problem is I'm thinking, do I need to run my model once again here, or else we already runs the model, we already got the PyTorch file, so I can directly write the PyTorch file prediction here. That's what I'm thinking.
We can copy paste this and put it in a method and run in Postman, right? Like we did in machine learning.
Yeah, that's what we're gonna do here.
It's a one-time run that we can do.
Yeah. So okay, I'll do one thing. See, what I'm trying to do is I'm already run my model here. I got my the PyTorch file. In a machine learning, we actually does the prediction on a .pkl file. So here we already done the code, the training is done, and we got a best weights here. Now what I'm thinking is, can I take this file directly to my file manager and I'll do my prediction? Or else what we can do is, let's take this all the code, put it here, let's run the API initially. Once we run the API, all the model will be goes once again and the file will be generated. Then from that file we will do the prediction. I think that approach is better. I think instead of taking the file from here, let's do it everything here once again. Okay, all right. So I don't do anything, I'll just simply copy the code from here and I'll just put back the code here back. Okay, so first is the device. I'll just go here. I just need a device code. Copy and put the device code here. Okay, so once we take the device, then the next thing is basically your class names, same as the training, person1, person2, person3, person4. Okay, let's take the class names. We know class names. Class name is equals to, I need to keep the same names here. The same names means if you go to my drive, if you go to my drive and here we have this class names, right? This is the same class names I need to enter over there. Okay, so Adishesha N space Bhagavi Sri Ram Sunil Adishesha Chakvi Dipti. And then Chakri Dipti. Arya, come on. Just give me a second, guys.
we have the print statement of the classes in that collab, right? Can't we copy paste?
Sorry, what are you saying?
In collab, we gave the print statement, right, for the class names. When
Yeah,
you
we give.
execute, you get all the class names there.
Yeah. Yes. Thanks. That's the good approach. Let's put the print statement here. But I need to run the model again. Oh, oops. I think we can type it because I need to run the model. It takes some more time. I think I done with Chakri Deepthi. Let's go and quickly type it. Okay. Chakri Deepthi. And then Monica Bhagavi. You also check here. Am I doing any spelling mistakes or not? BHRGAVI. BHRGAVI. Yeah. And then Sriram and then Sunil. Yeah. So I'm successfully taken all my required names here. Now the next thing is the transform one. Okay. Let's go. Data loader, we don't need this anymore. Resized image, this is what I want. I'll just put back here. Okay, so after this resized one, let's take our CNN model. Where is the CNN model? Yeah, here's a CNN model. Yep, I just kept everything. You can see there's one problem here. I think the problem is solved. Yes, one step forward. This one is here, this one is here, looks good. Close. This is perfect. Yep. So what's going to be the next one? Number of classes. Yeah. Why should I do like this? I'm just behaving like a stupid guy. Wait. Except the prediction code. Let's take everything. Copy and just put back here. Command Z. I'm just behaving like a stupid guy. I don't need this anymore. Let's put everything here, and the little changes that we need to do here. This is one step forward. Oh my god, copied everything. Close, close, close. Now close the epochs as well. Just maintain the distance. Take all this stuff from here and delete, because we already kept in the top. Okay. Yeah. So let's run this model and let's check whether the model is going to be saved inside our file structure or not. Let's do this. Okay. But if we're gonna do this, I also need to do one more thing. The one more thing is basically, if we just go here, we given the path is going to be from the drive, but we need the images from our local device. Okay. All right, from our local device we need the images. To do that, I will just download this from my drive into my local machine. Download it. It's going on. Okay, it's take a little time. Just wait for a couple of minutes, okay? Because it takes a little time. Yeah, it's done. Scene and image dataset 2. Okay, so let's go and go to the let's go back here. Let's copy this one. Go to the desktop, and where I have, where's the name of that my folder? Image predictor. So in my backend, let's create a subfolder called dataset. Okay, so now I'll go back. I got a dataset. Yeah, I got my file. Okay, so let's close this. Go back. So now if you see in the dataset, I got all the subfolders, everything. Okay, so let's copy the path of this one and close. Just change the path to this different one. Okay. Yeah. Oh, okay, we got this one, but we need from the dataset. Oh, what happened? I think I just made a wrong one. Copy the path. Oh, no. No, wait. Copy path. It's fine. I got it. From the data set, we need slash. Why no suggestions? It's fine. I will type it. Or else copy the path and paste this path. Yep. Perfect. I just got it. Okay. This is a path I have, and I got my path. Now, if I run this model, it goes on a loop. Okay, everything will work, and it will generate this CNN image predictor.pth file inside my backend folder. Let's see it will generate or not. Okay, I hope no errors will come here because all the required modules I have here, and I think I was getting a doubt on the CUDA, but don't worry, let's run this because the CUDA is available in NVIDIA chips, but in a Mac, I don't know the CUDA will be available or not. But anyway, let's run this and see what kind of error we will get and how to resolve it. Okay, just go and run this. Clear. Oops, we got a problem. No module name LZMA at line number 27. Line number 27. Don't play with me. Can you say line number 5? Torch vision. Touch vision. What's the problem then? From Torch Vision, import meta registrations dataset IO models options. Skip. Import. Okay, fine. Some modules are not found here. The only way is we need to take this error to the quen, because the quen will say what kind of modules that I need to install, because it's very hard to predict here what kind of module we need to install, guys, because the internal error, how can I do that? Okay, it's fine. I will take this to the quen. Not this quen. Maybe we missed a few modules. Let's see what's the modules we missed. Go quickly. What are you doing? Generate with answer. It's not directly related to your code. We know that, but where is the problem? Solution is you need to reinstall Python via PyEnv with proper support. Here is oh my god. I think it's problem with my Python. Yeah. It's problem with my Python. The reinstall your Python version. PyEnv install 3.12.1. Uninstall 3.12.11. Or yeah, it's version mismatches. What should I do now? Do I need to really do all this stuff right now? My bad. Okay, let's quickly do this. A step-by-step approach. Because that's not in my hands, guys, because my version is supporting for this one. Yep, just stick with this very next one. It's not problem with our code, it's problem with my system. Let's set up everything. I think it takes a little time. You have a 17 outdated formula install. Okay, fine. Go and Just do the quick setup of this one. Done. Now, perfect. Continue with installation. Yes. Downloading 3.12.11. Quickly go, go, go. This is a problem when we are doing everything in a live. So even if you get any errors while you're doing, definitely you're gonna face a lot of errors. Trust me, guys. Okay, you take the help of the Quen. Okay, where it solve the better errors. Okay, it gives the proper solutions for the errors in a Quen. Oh my God, go fast. Once it is done, the next step is we need to uninstall this one. Let's keep on installing. Arey yaar, come on. If it's taking so much time, then the only way is we can do direct prediction. Even direct prediction I can do with this kind of setup because it's my system problem. Bad day. Meanwhile, it will keep go. It will keep go. Meanwhile, let's do one thing. I will just keep this in my screen alive. It's going on still. Fine. Thank God it's done finally. Okay, it's done. And then now once it is done, no, it's done. Perfect. Let's check with this one. Everything is good. Now let's check this. Three point 12.1. Perfect. Oh my God. Fine, it's okay. It's working right now. But the problem is, Dataset, that is a problem at the directory. Okay, all right. So it's working good, but the problem is a directory. File not found. No such file or a directory data sets. Okay, fine. All right. It's working good. Okay. Yes. It's working. It's working. Thank God. Finally, it's working. Go. Just keep go. Yeah, So it's worked, and why am I getting anything here? Generate me a file. No, I think it's keep going on. It's keep going on. Go. Yeah, I just got the CNN image predictor.pth. Okay, so luckily I got this one. So there might be a chance, guys, because in a Windows you will also face this kind of issues, the configuration issues. Okay, all right. At the time, don't panic. Just take the help of any the AI tools. Okay, all right. Of course, I'm saying that because there is nothing wrong in taking the help of those things while you're solving the errors. Because if the error is from code, you can do this, but the error is from your local missions. Okay, the setups and everything. That's going to be very hard. Okay, that's why if you're facing any errors related to your configurations, just take the help of the GPTs or any things and just solve it. Okay. So finally, this is CNN image predicted TBH. We got it here, but you can't open this one. It won't allow you to open this one here, okay? Because we don't have a proper opening app here. But anyway, let's close this, okay? Now, once we have this CNN image predicted.pth here, now let's do the prediction on this CNN image predictor, okay? So then I need to load this file in my API. Okay, so now I need to work on my API. So hardly I think it takes 30 minutes, next 30 minutes. Let's quickly go and do that, and let's finish it. Okay, this is the most hardest part, but I can do. Once I have this, here I save the model. Let's close this one. Folks, save the model. I don't need epochs now because we already done the epochs and prediction also done. This code I will just simply comment, and also yeah, I don't need this all the code. I can remove as well because I really don't need this. Okay, because I got my required file. Okay, so now this is where we need to focus. I have this pure CNN, these two things I have. Now this is where I'm going to write the new code right now here. Okay, the new code is just load your model. Okay, load your model. Load the model means we need to load this one. Okay, the model is equals to the pure CNN, and to this we need to pass the length of your class names, and then you need to just give this one to your device. Okay, this is one step is completed. Next, model dot, just simply load this, guys. Okay, the load underscore state underscore maybe dict. Oh wait, then where we can say here torch dot load, and you need to load the CNN image predictor.pth. Copy path close, and you just keep it in this one, and you don't need this entire stuff. Okay, all right. So just load this, and after loading this one, there's a one small change that you need to do here, guys. Okay, the one small change is from where you are loading. You are loading this one from your local device, right? Then you need to specify your device, and that's it. Then you just simply say that model dot eval. Okay, yeah, so just go to the prediction directly. So this process is done. This is a simple model loading code into your local device. Okay, once we created a model, now here in the prediction stage, first you need to take data from your API. So I will do that. I will take from my API, don't worry. Okay, so before gonna do that, then I need to do one more thing, guys. Okay, the one more thing is, first of all, image name is equals to request dot form, and then image name. Dot form. There you specify. Usually if you go to your front end, what you are actually saying here in the front end, app.py, you are saying here files, not a files, image data. Perfect. Okay, that image data you're taking here. Once you take the image data in the API, then the new image path, testing image path, testing image path. So I will give this path later on, but before going to give the path, I need to set up something from os dot path dot. I need to join my image folder followed by image name. I will come to this. I will change this later on. Don't worry. Okay. So then I'll just go here. The next thing is, let's open an image. Image equals to image dot open of. You need to open this path and then convert into RGB, because the new testing image you need to convert into RGB. After this, the image tensor, the same thing whatever you done in this one. Okay, I'll just go back here. I'll copy the code from here, close, just go. That's it. Whatever you taken here, take this entire thing and just go back, put back here, but there's some small changes that you need to do. Now it's perfect, but you can see this is 2 times repeated. Remove 1 time. Okay, so everything looks good. The only thing is we need to give a new testing image here. The new testing image is, I will create a folder is images. Okay, return class name predicted item. let's print and let's see what is the output we are going to get. Okay, then finally I will do the JSONify. Of course here I'm doing the JSONify and I don't need any JSONify right now here. Comment this for some time. Okay, all right, so everything is done, the setup is done. The only change is I need to take this name images and I'll need to put the images here, the folder, image folder called images. See, whatever the name I'm taking here, I'm taking the same name here, images. Now the image name, what is the image name? I don't have any current image. What I will do is I already have a dataset. Adishesha, I will take one image, copy. I will pass this image to here. Oh, my bad. I need to copy. I need to paste it here. Okay, here it's safe. And I have my new image. I'll copy this image. Copy path. Go to sound.py and I will change this one here. Okay. Yeah, come on. Already we are taking the image from here, the new image name, and we are actually passing here. Then why do we need a separate one? I think we don't need that because image folder, image name.
Yeah, it should come from the front end, right?
Yeah. So I don't want to take a separate one. I can directly pass this image name. But the folder is we don't have any folder. Let's directly pass. Yeah, perfect. So I hope everything is done here. Now let's go and test this. Let's run this model. I think we no longer get any problem. If we get any problem, don't worry, we will resolve. Of course, we have a Quen. Let's run this. I hope definitely I'll get the errors. I'm sure about this one. But anyway, let's run this. We got a problem. Okay, the problem is to device the class name that were two were given. It takes a one positional argument, but I was given a two. Really, it takes one, but I was given two. Go where I was given two. I got it. Oh my god. Int object has no attribute two. Come on, something went wrong. For the resolve this, buddy. Don't waste the time. Let's give to the Quen. Quen will take it. We almost done right, but somewhere we can definitely make the mistakes. You're on the right track. Yep. But what's the problem? Okay. Passing an argument. Request from images from. You are sending image files not from data. Okay. From image data. This is wrong. Give me the corrected one. Sending raw bytes with wrong key. Okay. This is a fixed Flask server. Let's see this. What's the mistake that we actually done? Load class names. Is this mad? Okay, so it's storing an all class names in a JSON one. Oh my god. Fine, I got it. Number of classes. Number of classes. Length of the class names. 7. To the CNN model, we need to give the number of classes again here. Okay. All right. Okay. Files, image, data. Files, image, data, uploaded file name, uploaded file dot get value, file type. All three sending, but one is enough for us. Files. Arya, I'll take this code. I can't reconstruct. Remove all exception handling code. Just give me a plain one. Just give me both front-end and the backend. So in the backend code, there is only one change, guys. That what is the change? I will tell you. Don't worry. The change is basically they taken in a JSON file, but I will directly give this. I will hard code the data here. That I will tell you what is the change. Don't worry. I will change this. I will change this. Don't worry. And then the next one is this code is remains constant, but yeah, this code is remains constant everything. But there is a change in a front end, guys. In a front end, now everything seems to be good. The only change is just a one change. There's a one change I need to do, but anyway, I'll take this from here. Let's rechange this entire stuff. Comment port 5000. That's fine. here we don't need this. Here one small change. The change is the number of classes is I'm directly taking the 7 because I don't need, because they are saying that class names.json, one separate file they are opening, from that file they are reading, and I don't need this because we have a total 7 classes. I'm directly doing the hard code. Okay, all right, I don't want to confuse this one anymore. Remaining rest of the things are going to be the same. The class PUCN is same, and here number of classes I'm just passing this number of classes I'm passing to my pure CNN, and this one will be goes to my number of classes. Total 7 classes, and the 7 classes I'm passing here, and 7 will again go and it will store here, and rest of the things are going to be the same, guys. Okay, as well as I said, the load state dictionary, the torch load, it's loading, and the map location is device, and the model dot evaluation, that's the same thing. And if you just go to the prediction, this is also done. We done the same thing, but the problem comes at, if you go to the app.py, what they changed. Oh, I have a 2% charging. Just give me a second, I have a 2% charging. Yeah, if you see here, the only change here is we taken only upload file dot get value, but they taken upload file name, the value, and then uploaded file type. Okay, they taken this all the values and they stored in an image data. That image data they're passing like a files here. Okay, but what we done here is, if you just go and check it out here, file content we taken instead of the different variable name. Okay, so upload file, we taken a one value and we pass in here like a JSON. Okay, that's the mistake I done, but anyway, that they are doing the separately. Okay, all right, even we directly taken this and we passes this one directly here. Okay, all right, so now perfect, everything looks good. This is one change here, and the another change here inside this one is the hard coded value, the 7. Okay, all right, remaining rest of the things are going to be the same, guys. Okay, all right, so now let's just go on this. Still I have a problem here. Class names of predicted items, my bad. The class names I need to take, because again we get a problems. Class names, because I never define a class names. Class names is equals to, I need to type all my class names. Am I typing here? No. Chakri, Deepthi, Monica. Bhagavi. Sriram. Sunil. Yep. How many numbers totally? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This is good. Okay. All right. So done. I just done with this one. Okay. So now let's run this.
Spelling wrong. SESHA.
Okay.
Class.
This is perfect. Okay. Yeah. So it's working. The backend is working. Okay. So now let's just go and test it with the front end right now. Okay, image prediction API is running. Good. Go with this one. Okay. So now let's just browse the files. I'll take an image from here. I'll upload. So if I get a Deepthi, then I'm the most happiest person. Okay. What we get? We get errors. And just go here. Let's see what we'll get. So Pam, let's go undo this. Here we go. 3, 2, and 1. It works. We got prediction is Deepthi. Is this a Deepthi one? Yep. Arya, where is my images, guys? Yeah, it's a Deepthi one, right? You can see here. Yeah, rashmika.jpg. Yeah, it's working right now. The prediction we got, it's going to be the Deepthi. Okay, so whatever the image that you upload here, and yeah, so Pam, it's hard, but we made it, guys. Okay, all right. So we finally got it. The model is properly working fine. So all the end-to-end flow is done. Of course, we faced the errors. I know I'm not a robot to do everything in a proper way. Okay, so to be frankly, I'm saying it's very hard, but we made it. Okay, all right. So I hope you got the idea what the changes that I actually made in the actual code. So now this is the same code for every image model. Every image model, this is the same piece of code that you follow. If you're trying, if you're training 2000 images, 10,000 images, it doesn't matter. The only change is for prediction, this is a code. For model running, the code is here. So this is the model running code. Okay. And this is the prediction code, guys. Okay. All right. If you have these two codes in your hand, you can literally train 1 lakh images or 2 lakh images also. I will give you a source where we have a 2000, 3000 images. So I will share that inside your group, what kind of tasks that you need to do. Okay. Just do your task, create your own images if you really wanted to test that in a proper way. Okay, all right. So then everything will work. You can take your family pictures, 20 family pictures. You can just implement a model, guys. Okay, then it will predict a proper image whether it is your family member or not. Okay, but all you need is the more data. More the data you submit, it works in a more accurate way. Okay, all right. So that's it. This is just an image prediction. I will scale this model little bit to the higher levels. The higher level is if you submit a new image, it is predicting whether that image is related to Deepthi or Adishesha or anyone. But the little scale means let's take a bulk of images. From that bulk of images, where we're gonna train, and we will write a prompt in a text box. Can you please generate me a lion image? Then it generates the lion image. Can you please generate a different image? Then it will generate a different image. But all you need is the so much bigger database of images. Okay, I have a sources. That's what my next move. Okay, so we will be working on image generation, the reality. Okay, how chat gpts, how groks, how gemini models, how those models will generate images, I'm going to show you in the very next class. So meanwhile, you guys please build this project. Okay, I will upload this code into the uh, the GitHub. I will share the URLs with everyone. Okay, all right. So that's it. This is for today. Yep, someone is talking.
Yeah, Prashant. If I want to find out the duplicate pictures, right, is it the same approach that we should do?
So, sorry, what you're asking? Duplicate?
I want to find the duplicate images, right? Let's say I have my phone library. Okay.
Yeah. You have your phone library.
So, okay, I wanted to find out that when we click the pictures, will we keep clicking the pictures, right?
Yeah,
Like
you're
if
gonna
you
keep.
take 10 pictures,
Uh,
if there are 10 pictures, 5 of
yeah,
them is going to be like 95%, 99% is going to be matching.
similar
Okay,
similar
how do I
pictures.
yeah, correct.
No, it's
So
fine.
if I wanted to find out that, is it the similar kind of model that we should use, or
Like how similar those images are.
like everything is going like, let's say an example, right? When you are taking a picture for an event, okay,
Uh,
for
mm,
one picture, one pose, you'll take, generally people take like 10, 20 pictures. The phone is filled
yes.
with all the pictures.
Yeah.
Okay.
Mm,
But in that 19, like a lot of my images are going to be same.
yeah.
95%, 98% it's going to match. It's
Mm, mm,
duplicate
mm, mm,
pictures,
mm.
right? So if I
Yeah.
wanted to use this, is this the same model that works or it's a different?
The same model, but the only change is, imagine you have a 25 pictures of a person. Just put
Uh-huh.
all the 25 pictures in a folder, and then take any new picture, and that new picture you just submit, and just see the probability how close it was.
Yeah. So you need to see the probability of the clothing, right?
Yeah,
Here.
exactly. You will get the probability here, right? You can see the probability. Okay, so the final loss, it's going to be, you can see at the 10 out of 10, it's going to be
Uh-huh.
0.0194 you're getting. Okay, this is the final loss that we got, and that's the probability.
Uh-huh.
Yeah, so then you will
Got
get this.
it. For you should do it for each picture.
Yeah, you need to do for each pictures, like how similar it will be for other pictures.
Got it. Okay.
Yeah, that's the way you need to follow. Okay, right. But what is the purpose of doing that? Like how similar it could be with other images?
It's a duplicate picture for duplicate finder. Right?
Okay. So it's a kind of duplications finding that another image and
Correct.
this image, how close it is. The finding the duplicate images.
That's,
Yeah, that's so the
yeah,
same
yeah.
model. No change. No change. The same model.
Okay.
Yep.
That's it.
Okay. All right. So see you tomorrow, where we can actually work on a image generation tomorrow. Okay. So now everything will be same, but I will add a little knowledge to this model where it can generate the images. Okay. So all right, guys. See you all, guys. Tomorrow, same time, same place. Then take care. Bye bye. Have fun.